think I got everything. Turn on the scope. Whew, I'm back. I'm back. Had a bit of an emergency fashion emergency. So I didn't stream on Friday. I had to find shoes that I could wear in polite company while not being too formal, but not wearing boots. It turns out that this close to the holiday season, it is impossible to source certain things. And so I'm not going to get the look that I wanted to get out of these shoes. I wanted to have a particular look to the shoes, and instead I'm getting very boring looking shoes. Oh well, that's shoe shopping for you. I should have done this months ago. I had to settle. I had to settle. In the end, I might actually end up wearing my boots, my Finnish army styled boots, because under the pant legs, they still just look like informal shoes. All right, let's get YouTube comments up on screen. I got to do that. That's a whole process that I have to do after I started streaming. The whole getting dual chat working is an unbelievable hassle compared to what I used to do in order to get stream running. But I don't know. It's worth it to get the YouTubes. Hey, what's up, Wonky Robot? Your comment did not make it up onto the screen because I haven't opened YouTube in an independent window. So this window here is an independent account. It's not a moderator account. So what I need to do is go to YouTube at OhBotherVOD, which is the channel. I made a VOD channel. I probably shouldn't have. I don't know. What do you guys think? Should I have just put it on the main branded channel? Because the main branded channel is really for edited videos, but I haven't been doing edited videos. I need to make edited videos and resurrect the other account, the OhBother account. This is OhBotherVOD. Oh, whatever. Either way, here's the live stream here, and now I can pop out this chat. Bonk. There we go. All right, so now YouTube is properly represented. The thing is, the Twitch chat is always up. I can go to this URL and it will always be my Twitch chat because it's an IRC channel. Whereas YouTube has its own little contained thing, and their own little contained thing has its own little unique URL because each stream has its own V equals value. So I can't just have an automated, like a button that'll just pop up the popped out chat. I have to go to my channel. I have to watch my own video, which is a little bit, that's a little vain, isn't it? To watch your own VOD channel? That's a little vain. But anyway, that means that all of the chats end up on screen. So, whoop-de-plop. Fusion is still running. Is there any updates? Nope. Yeah, so we're going to do a little bit more of this. A little bit more of getting the schematic up, and then we can start to arrange the 2D parts to where they'll be. And then I forgot about this, but apparently I have already decided to do a 4-layer board. So we're going to do a 4-layer board on this. It'll be my first ever 4-layer board. We made it in the end. Yeah, we got you up on screen eventually. We did it. We got there. We got there. Like a circuit thing. I don't know where the thumbnail's gonna get scraped from, so I want to have always have good images up on screen, so it's not something stupid and embarrassing. Ugh. My folks make this amazing orzo salad, and I've got a tin of it in the fridge. Not a tin. It's a Tupperware container of it. It's an orzo salad, and it uses egg whites in the dressing, and it's very fancy. You have to make a roux for the dressing, and it's got prosciutto, and it has artichoke hearts and whatever the hell kind of cheese, I forget. But it is absolutely, I could eat pounds of the stuff easily. But I had a little bit of it ahead of time, and the slight acidity, the lemon stuff that's in it, is going to make me burp. So I will have to mitigate that. I'll be burpy for a little bit. Let's what up, Bothan? How you doing? Let's get a little bit of sense out of all this chaos, huh? I'd like to actually be able to use my computer. Right now, it's just all this stuff in the way. All these things are in my way. We've got the mixer design is all vetted out. There's not much else that we can do with it aside from putting audio through it, which is I'm gonna have to figure that one out. I don't know how I'm gonna put audio through the mixer design, but I can clean up a couple of these little spaces here. Maybe we'll just put this up there for now. Does that even fit? Oh, it doesn't even fit. I'd have to scooch over the other piece. I have to get into menu design to make the module tester work. It's going to be kind of a crazy build. But this is the mixer's practice for all this, because the mixer is going to replace this. And that'll be my attenuation for the output. All these projects, all these fractal yak shaving projects, they the closer in you look at the project, the more complexity you find. That's sort of where we're at right now. We are in the throes of the yak shaving Olympics. And eventually, what's going to happen is the yaks are going to start becoming bald. And once we embaldinate a couple yaks, the area in front of us is going to be clear enough that I can get back to burn the subs. But there's a lot of synthesizer work until then. When you do projects the way that I do, kind of organically, this tends to happen. You got to watch out for it. And hopefully I can get my concentration mojo flowing again. I need to make some phone calls and ask, where the hell is my prescription? What's going on? And try not to be rude to people whose jobs it is to deal with rude people all the time. Maybe I'll actually get something to happen. Because I don't know what the hell happened. The doctor said that they put in the pre-authorization, and I've been taking this med for nigh on 15 years, and now I get no response. Not even a denial. No response at all. So I think some ball was dropped somewhere. Some kind of a ball dropped, and it wasn't the New Year's kind. Empty desk, empty mind. Let's clean up. How's everybody else doing? We're doing kind of a Saturday stream. It's going to be a little quieter. Normally is on Saturdays, but I think we can get together quite a bit of this design and make some significant progress, because getting this whole circuit working was one big piece of progress, and now getting the design in the computer is going to be another. I can't wait to actually order the circuit board, and I don't know when that's going to happen, but we've got a couple things to work out until then. We got to put one more part into the CAD program. I got to make the audio amplifier, which isn't that big of a deal. It's actually going to be quite easy now that we know the process for making parts, which is not an easy thing to figure out in Fusion. But once you get it, things click, and you can really run through a design very easily. You know, the biggest problem with Fusion is parts, and I guess that's the same thing with any CAD program, is that when you're doing a project, there are going to be some parts that aren't really represented in your CAD program, and so you have to figure out the process for adding them in. And that can be like pulling teeth. Once you have all those parts, everything comes together pretty smoothly. So we're one part away from that. I finally have time off, so I'm over the moon with that. Forgot how nice time off is. Yeah, that is nice. I took a vacation once. We've been streaming pretty solid for a while, and due to the nature of streaming, working during holidays is actually quite beneficial for my numbers. Saturdays are not beneficial for my numbers. I do Saturday just because I do Saturday. But yeah, the holiday season is when everybody is stuck at home and they can watch stuff like streamers they haven't watched in ages. This is all garbage. All of this, all of it except for this stuff. This is just the detritus that collects when you breadboard and perfboard. So Willow was my dog, my corgi, Willow. She was sleeping under my desk just behind me. Right up until, she was perfectly content and happy, right up until I touched the stool. And the stool represents streaming, and streaming represents me yelling at the furniture. And so she immediately got up and left. Which is it's very annoying because she's super duper cute. And it would be great to have her on camera, but she has decided at this juncture in her life that she's not going to put up with me sitting here yelling at the furniture. So we don't have the dog as a co-pilot for the stream. Excuse me. Going back to work is going to be the hard part. Yeah, always is. I had this thing this morning where right when I start to fall asleep, I wake up nauseous, like a huge wave of nausea and like panic. I think maybe like my airway was being closed off or something. It was a very weird thing, and it's very jarring to try to sleep like that. It sucked. It was really bad. 104. I gotta put these back, but I don't want to just put them back randomly. 102. 103. 103. Instrumentation, what are they? Instrumentation potentiometers. These are really good to have. They're really good to have. 102. Because they're accurate, they're adjustable, and there's a wide range, like a hugely wide range of them. So they're really good if you don't know precisely what value you're going to need for something, or if you need like a precision trim. Putting those in is just wonderful. Unfortunately, they're big. They take up a lot of space. So in our particular design, with all the trimming that I'm going to have to do on this thing, all the analog trimming that I'm going to have to do, they don't really make that much sense. And they don't survive the tiniest amount of direct LED dimming. What did you do to yours? Did you put a bunch of current through it? Yeah, I wouldn't put a ton of current through those. As with anything, everything's getting cheaper and cheaper, and that means that they're using worse materials to build them. Cheaper materials mean less robust devices, and then you get yeah, LED blowout and stuff like that. There we go. There's a good scene. I should figure out how to run computer audio into this thing so that we could have, you know, like the waveform popping off and stuff like that. Right now we're just mixing basic waveforms. What happened? Oh, I hit reset on the Arduino by accident. There we go. There's all our waveforms. What? Why isn't that adjusting? Hello? Ugh, this setup gets a little wonky. Yeah, there it is. This is why I want the PCB version of this, because with the PCB, you don't have all of the weirdness of your signal path being on janky connections. I don't know what it was doing before with its like totally blown out. Yeah, I get little distortions. Do you ever use the Fourier transform, EE major? You know, if I was doing particular things, yes. Familiarity with it, the ability to know what it is and know where it's used is more important than actually doing it, because I don't sit down on a piece of paper and do a bunch of equations. I hate them. I hate doing bookwork. There have been times when I've been backed into the corner and you have to get a transfer function for something. Like that happens more in analog, the stuff we're doing now, than you would believe. But like, I generally don't sit down and do a Fourier transform on a waveform. I have in the past used the scope in order to do that, just to get the fast Fourier transform of the frequencies that I'm getting in. And we'll probably need to do something like that in order to do an analysis of the mixer at some point. I haven't done that. Basically, when I started the design, I put in the C note and I put it at maximum amplitude. And I'm only concerned with amplitude so far. I don't know what the frequency response is going to be of my entire system. That worries me, but the TL074 equivalent-ish op amps that I chose should be up to the task. They should handle frequencies, especially in audio, really well. Audio frequencies of nothing on RF, and you know, I'm designing it kind of RF-y capable. Although the V2164, I think the frequency response is pretty good, and there's a little bit of noise filtering from the headphone amp, so that should probably be pretty good. I don't know how, you know, sprinkling it with capacitors is like a dark art that I don't know. It's evil magic. The Dwemmers were cooking when they invented capacitors. And then as a result, we're all cooked. Do you ever use Bode plots, or are they irrelevant? What the fuck is a Bode plot? I gotta remind myself. Listen, I've been out of school for quite a while. Oh, I'm gonna cough. Oh man, okay. Oh, let's see here. Which one is the Bode plot? You should know what a Bode plot is and how to read one. They come up in data sheets. Because if you want the frequency response of something, I mean, just simple enough. Like here we are. Here's our data sheet right here. It's where did that go? Where was that? So yeah, you know, like this, you want to know, like, you need to know what a Bode plot really is and what it represents. There we go. So I think I've proven my point. No, so Bode plot, like, I mean, honestly, like, you see them in data sheets. B2164, it's a current amplifier, a current controlled transconductance amplifier. And so one of the big components of this thing are the frequency response of the internals. And so here you have a bunch of stuff that's related to that sort of a plot, you know. So you want, you know, familiarity and ability to interpret. But generally, my eyes gloss over, and I just don't pay attention to this stuff. I just don't pay attention to all these wibbling lines. And when I do, you know, you hunker down and you kind of really figure out exactly what's going on here. But I generally try to avoid it. I figure the V2164, having been used in a design that I respect by a fellow musical instrument creator, gives us that sort of shoe in on choosing parts. Like any of the 2164 family of transconductance amplifiers is probably great for my audio design, because they're coming from a company called Sound Semiconductor or Cool Audio. Audio is sound, it's all in the names. Yeah, going from time to frequency domain is very confusing. Going from current domain to voltage domain is also just annoying. And it's like, you know, frequency and time domain, it's like bending your brain about how things work. What was even crazier was at the end of my curriculum in, what did I fucking study again? Motors and control systems. We went into, just briefly, did some stuff with transformers. Not like robots in disguise. I mean, like, there's this block of iron that you make wibbling magnetic and electrical waves in. And the thing is, in the magnetic domain, when you turn over to magnetism, there's a particular way that you do it, all of your equations change, but they're all still the same. You have RLC, resistor, inductor, capacitor, right? RLC. And RLC calculations, you know, you get familiar with them by doing, yeah, I'm back. I'm back on a Saturday. You get used to kind of RLCing all of your equations and stuff, right? When you move into magnetism, all of a sudden, you have RLC, but you're talking about magnetic waves inside of a block of iron. It's crazy stuff. It's like, whoa, wait, I already know how to do all this stuff. It was really cool. And then I immediately forgot about it. Like, as soon as I took the test, I forgot all about it. I need like a refresher course on that stuff. The other one was balancing loads on transformers, which is very similar to working with speakers and stuff. And that's one thing that I didn't really, I did the, you know, we studied the material and I said, wow, this really clicks. And then as soon as I took one step out of the building, all of the knowledge leaked out of my ear and I forgot about all of it. So what is that adage about engineers? They've forgotten more math than you've ever encountered. I'm living that dream. This thing still gets uncomfortably hot, doesn't it? Ow. 3-volt regulator in this thing is barely spec'd to size. I should probably put an actual heatsink on it, but this is just temporary. This is eventually going to become a full-blown circuit tester. What's up, Madam? How you doing? Retro Maximus Plays. That's a heady screen name. Welcome, welcome. Yeah, so we're getting close. Hey, what's up? We're getting close to doing, like, putting traces down onto the board, so that'll be cool. At Berkeley, we do mostly math, and we see actual circuit. We're like, what? Yeah, I've had professors complain about that. You know, the kids are graduating and they don't even know how to solder. Like, at Drexel, we did a little bit of soldering 1,000 years ago when I was in college, and then I got to work in the high voltage labs, which was cool. But I never had the credentials. Like, you had to be going in for like graduate in order to do the really cool stuff. What we were able to do is a couple labs, and you're just following instructions. But the cool thing was they would shut down all of the high voltage stuff. You could then go hook everything up. You know, you get exactly the cables you need, and you hook them up just precisely the way you do it. And then they would get everybody back behind the line and then energize everything. And it would energize by an actual generator that was in, like, you could listen to the thing turn on. It was in one part of this like industrial bay, but it was a basically mains power comes in, spins the motor spins another motor, and that motor then powers up the entire high power lab. So they sort of made their own circuit so that they didn't blow up the grid in the area. Well, hey man, you know, I cut my teeth as a suburban idiot rich kid taking apart all of my fucking toys and none of them going back together. You ever play with Verilog? I've been meaning to for a microphone filtration project. Although, to be honest, I may just build it into a box because I want to get rid of all of my audio shaping via electronic means. Like, I don't want these filters, these VSTs, to be, because this is like when you're broadcasting, once everything works, it's like this big house of cards that you don't want to disturb. And so I've got my audio filtration and compression here. I would like to move that over to a new thing, and that way I could have that thing, and if I ever had to take the show on the road or anything, I could bring that thing with me, and that is my signature sound thing. Verilog is every evil bit bash, but an entire language of it. Love how some companies just ship FPGAs and forget the ASIC part. We haven't dealt with it yet. I've got this really cool FPGA that I've been meaning to use. Let me find it. Ow! This bin. I need to get a new bin. My microcontroller bin. Where is that thing? I think I see it. Oh no, that's not it. Where did it go? That ain't it. That ain't it. I haven't even soldered, like, pins on it yet. I think it's over here, maybe. So what I have is the tiny FPGA. And I guess it's getting a little old, but I haven't really found a project for it. You see something like this, and you kind of go, ah, I should do something with that. And then you buy it, and then it ends up collecting dust for years. Where did it go? All right. So I've lost it. I think it's in this bin somewhere. I just haven't... I need to, like, dig it out from wherever it's hiding. But it's a stamp-sized FPGA development platform. And it's USB. I have absolutely no idea how to run it. Absolutely no idea. I would have to start researching and then learn Verilog or whatever the hell else you need in order to program FPGAs. Why am I getting a cramp? Diabetes is striking again. Fuck you, diabetes. Leave me alone. See if I can spot it from underneath. Why isn't that closing? Oh, because of this relay board. All you need is a compressor, and EQ, and reverb. I don't need reverb. No. We're talking about my microphone here. You don't need reverb on your mic. Where'd you go, FPGA? No, see, what I need to do is build into a box a dual compressor and a dual EQ circuit, which gets big. There's a lot of components to that. Possibly do like some kind of a special thing, like, limiting. I don't know. But my audio is fairly simple. I like one-to-one reproduction. My voice, unfortunately, is not that deep. If I was to try to get my voice to be appropriately deep, I would need to have some kind of over-edited, what do you call it? Overproduced audio. And you can just tell when somebody has overproduced audio. I don't want to single anyone out. I don't want to name names, but there's one creator that does some pretty crazy stuff with the games that he plays. He does some pretty amazing stuff, finding how to make a game go completely psycho. But his audio is so over-edited. It's bad. It's like my subwoofer's doing double time just to have the guy talk to me. I can't stand it. You can implement your own CPU and an FPGA. Yeah, but why would you go through all that trouble? You can drag and drop a processor into an FPGA. You can buy like an Intel core, but it's like, why? Why would you do this? I guess that makes a lot of sense in game emulation. You can have the exact processor that you would need in order to have the effects that you would need on the screen go through fully. Verilog is a lot like C. HDL is a different language you can use. There's a couple, right? There's like Verilog. I know of one other that's not HDL. What was Scanlime using? She was using, oh God, I forget. Scanlime is a channel that I've slept on for a while. She's awesome. Came up recently because somebody was working on like tablet stuff, like a project involving tablet stuff. And I was like, oh, I know exactly what you should be looking for. And it was this awesome, Verilog is not a program. All right, whatever. Whatever. It's all Nintendo. Everything's a Nintendo to me. I'm going to be like my parents and just call everything Nintendo. What's the one where you lay out like the logic gates in like ASCII? Which one is that? I've been meaning to try the tiny FPGA too. Mine's old. I can't find it, but mine's like an old one. I bought it like at the initial release of the tiny FPGA. I don't know what happened to it though. It's around here somewhere. Oh, there's the tiny heatsink that I was looking for. Oh. Can we somehow put this on? Yeah, let's put this onto the thing that I'm working on. Oh, this is a mini project that I think we should get to soon because it's that season. It's not quite that season. That sounds like hell. Yeah, it is. It is. This thing is I don't know who makes it. Hold on, I'm gonna die. This is the thermal imager, and it's a really cheap one. It's not good. The thermal imager that I have on the camera is a Lepton 3.1 system. These tiny little thermal imagers have been making their way into all kinds of cool stuff, like mostly like gun stuff. But there's, what is it? Hollow Sun now makes a red dot that has the ability to also project like quality enough, if you're shooting stuff that's warm, thermals onto the red dot. It's pretty crazy. I like want one, but it's $1,500 that I definitely am not going to spend on something like that, because I don't shoot things that are warm. I don't live on a farm. I shoot paper. That's the entirety of what I shoot. So I will never shoot anything else. Never, never. Unless somebody flies me to their farm and they have a prairie dog problem. But that's not going to really happen. So anyway, getting something scary like a thermal sight is sort of not in the cards. Have you ever made your own ASICs? Fuck, what are you asking me? No. What do I look like? Fucking Nile Red? Why would I reinvent the wheel on that level? In order to make an ASIC, you go through a whole design process, which involves what I like is a glob top, which sounds like some kind of a racial insult. But the glob top is this epoxy shell for a chip that has all the center part, you know, not filled in. And it's got all your stuff, and they plop down your silicon wafer and do the gold bonding wires, and then they put epoxy on top of it, which then looks like sort of wavy epoxy. So it's a glob. But yeah, that I've seen the process of attempting to make an ASIC, and it is an industrial process, and it takes a lot. Why is it writing stream will start soon? Because we haven't started the stream yet. I got to explain this literally every stream, is that when you see the splash screen with like a timer on it, it means that your streamer is pooping or plugging stuff in, or, you know, your streamer is there. Their OBS is running. It's exactly what we're doing right now, only I have the balls to have the webcam going on at the same time. I don't care that you guys see that I'm picking my nose and scratching my balls. That's, you know, this is time for us to hang out and just talk about whatever, which is literally what we're doing right now. We are not doing the hashtag AutoCAD ad right now. This is the pre-stream where I sit here and I chew the fat with you guys and we get ready to do the stuff that we're going to do on stream. It's not TMI. I'm going to continue to talk about this stuff. I did the same thing when I first came in. Yeah, but you don't have a friggin' webcam up your nostril. I got this thing's like right here. And it's like, should I? I'll do it. I don't even care. I'm on camera. I'll do it. I'm not gonna actually pick my nose on camera. That's rude. I want to attach this heatsink. I have somewhere around here. I have copper heatsink. That would be much easier for me to attach. Ugh, there's like goop on the back of this thing. I just want to put this little tiny heatsink on here so that we can dissipate the heat a little bit. Maybe I'll put it on the back of the... Oh, no, I can't because the rail's right there. How would I attach this then? Well, I think I need to find one of the copper ones. This thing can manage itself for now anyway. The voltage regulator, this little heat source right here. Nose pick, not again. So this thing that I found that I got distracted about, this is a crappy thermal imager. This thing barely makes an image that you can see. You can't really make out what you're looking at. The thing about this is, this would be really good at finding dog poop. And so what I'd like to do is make a 3D printed shell so I can just toss this in my jacket pocket. And when the dog poops and leaves, I can then pull this thing out and have some kind of a laser beam that locates. So if I can find something that's flat, I would like to really find a flat laser. I'm gonna sneeze. Oh my God, that was a dad sneeze. I just screamed. I would love to find a laser line projector that's flat. What are all these? Wait a minute, what is this? Orlin the Mage has gifted 10 subs. Dude. Well, thank you. I really appreciate that. And that's a genuine... These are going out to a bunch of different people, but we got Gordon Roy, Quiet Mercenary, Peace Frog 71, Wodo Weasel. Yeah, that's actually a friend of mine. S85525D, Jajanix, Lolly Lol, 1975. Oreo 98, Rum Zombie, that's a good one. Peter F 81. Hey, thank you. You guys all owe Orlin the Mage. But yeah, this will be the Poop Finder 3000. And so I need some kind of a way to laser out of the front of this so that I can see stuff. And then I'm not gonna just fill this space with a lithium ion battery. I think what I want to do, instead of filling that space, I'll just do an 18650, like slung on the bottom or the top. And then it'll become a little larger. It'll become a little bit more camcorder-like, but then I'll be able to have a laser locate. See, if I had a lepton core and I was able to see that on this screen, then that would be much easier, because you can see shapes in the thermal image here, right? Like I can tell where these speakers are because they've got a little bit of contrast for the temperatures around them. This does not have that kind of pixel resolution. It's a very cheap thermal imager. I mean, the other thing I could do is maybe like guide a missile with it and then get arrested federally. But yeah, so have I ever been fucked over by high voltage? No. The thing is, we don't mess with high voltage here. It's a very important thing. I could be like Uo to Oo, or Uo's Lab. Sorry, he rebranded. Uo's Lab does all kinds of crazy shit, and he does it like totally cavalier. I caught him cutting sheet metal with bare hands, and I harkened back to a time when I was doing this stream early on when I was doing brewing stuff. I decided I'll just cut this duct before I start stream. And I cut the duct, and the duct went spring, and I was like, huh, that was weird. It kind of did a sudden movement. I had a huge gash in my palm, like huge gash. So I had to very carefully kind of put it back together, put glue on it, gauze, wrap. Yeah, exactly. It's a great way to slice your hand open because those cuts are incredibly sharp. And in fact, the cut went back together so well, I don't even have a scar. Or maybe it was this. I don't know. Anyway, either way, I don't fuck around with that kind of stuff because I'm always on the unlucky side of getting injured. Just don't. Like PPE is important, all that stuff. I make it look a little bit cavalier. When I do the bandsaw over here, I make it look cavalier. I make it look like I'm not actually doing all that safety stuff. The thing is, I know my tools very well, and I'm very careful about that point where you become complacent. You kind of become comfortable in what you're doing, and you start to round around the edges a little bit, and you kind of forget, oh, I don't need to worry about this. I worry about it constantly. When you get comfortable in the shop is when injuries happen. So I very much want to avoid that because I am already covered in scars. I'm also a type 1 diabetic, and I have an insulin pump pod on my body along with a constant glucose monitor. They like to prescribe you exactly as much as you'll need to get to the next appointment. And so in doing that, if I expose myself to high voltage and something goes out, I'm out of that thing. And I have to spend hundreds of dollars to replace it because they only prescribe you a certain amount. It's crazy. So we don't fuck with high voltage. I once got when I bought the 3D printer like 8 years ago, I got with it a miniature Tesla coil, and I plugged in the miniature Tesla coil, and we were able to play a little bit of music through it, and then my lights turned off. They just went off because I have a capacitive touch. It's tucked in behind there, but there's a capacitive light control back there, and that apparently popped off with the miniature Tesla coil. So it's like, you know what? I'm not gonna fuck with anything high voltage. I'm just not gonna do it. What are my glucose levels doing right now? Actually doing pretty good. I run something called AAPS, the Android Auto Pancreas System, and that manages my glucose levels in the background. So while I'm talking to y'all, this thing is going, whoa, wait a minute, that glucose level's going up. I need to give these little micro boluses to bring it back down. So this is it's a third-party management software for diabetes that works with the Omnipod, and it works with the constant glucose monitor that I have. When you have that cookie? No, it was an orzo salad from my folks. My folks make this really good orzo salad. I've made it too before in the past, but they have their very specific recipe from like a 1975 magazine, and it's a really good orzo salad. It's got prosciutto and artichoke hearts and Parmesan, and this wonderful roux that's a little bit tangy and spicy. Well, not spicy, just tangy, like with lemon juice in it. and orzo. It's so good. All of the component parts of that go together so that you just get this beautiful salady, light sort of whatever. It's pasta salad, but it's really good. I got very comfortable putting knife blades on a machine. Used an electric ratchet, the nut to snug it, spun the blades, sliced the skin right off my fingers. Never forget to use PPE. Holy fucking shit. Dude, that sounds nuts. Oh my God. Yeah, I was watching one of the many Australian machine shop videos. I love those guys. They're so, I don't know, they're so lackadaisical about PPE. It's kind of incredible. Oh wait, are we 10 more? What have you done? Orlin the Mage. That's 20 subs. Orlin the Mage, thank you so much for gifting. Here, more money for you. Thank you. Thank you, thank you. Thank you, thank you. Yeah, you guys who get subs from Orlin the Mage, thank him very much. The new user that's just like, hey, cool channel. Here's a ton of money. It's always fun. Yeah, but these Australian makers, right? They're pretty popular on YouTube now. I know a couple of them. I don't personally know them. I know their channel. And they're like barefoot in a shop that's a garage that's filled with stuff. And there was a video that released today, because it's Saturday, this is when all the machining videos come out, where he's using a drill press, one of these guys. I'm not going to name them, because I think there's probably like a TOS violation if I do something like that. But we're just sitting here drilling away on a hole with this probably 50-pound piece of welded material that he's building into one of his machines, and it just catches, and that whole thing whips around and then whips at him, and he kind of just like gets out of the way. But when he's getting out of the way, there is an engine stand that he has to step over in order to get out of the way of this flying piece of 50-pound like angular metal. You can fucking literally lose a toe on something like that. It can come down on a corner and your toe will go in the opposite direction of your foot. Like, holy shit. Yeah, so you are the softest thing in the shop. Remember that. You're the softest thing in the shop, and you're the only thing in the shop that will heal. You know, what you're working on, the thing that'll make your boss a new vacation home, that thing will never heal. But you will. So throw yourself into the machine before the workpiece gets hurt. Because, yeah, we get to heal. What we're working on doesn't. Yeah, I got hit in the chest. I can't believe that. That was nuts. It's like, dude, put on a boot. It doesn't have to be a steel toe boot, but just put something on that's going to cover your dogs, man. I'm taking time off. I fucked up my foot. I have managed to not totally mess myself up, but I have some stuff that I need to do, and especially with like rebuilding this machine, which has never been rebuilt, and it's all out of whack. Everything is unprecise on it. Yeah, and clamp before drilling at the very least. Especially something like that. Good Lord. And then all these machinists, right? Not just the Australians, but all the machinists. They run their machines at like the cliff's edge. They're like, I'm gonna CNC this thing, and it's like maximum speed, and the fucking end mill is like, please kill me, please God kill me, and then eventually one of them pops off and explodes. My thumb is a clamp. Yeah, no, like they run their machines at like the ragged edge of what it's capable of doing, because they're like, that's what it's capable of doing, and so they'll just crash these end mills all over the place. It is. I die every time I see these guys doing this stuff. Like, oh no, I popped another spindle because I tried to save 20 minutes on the machining process. Those CNC mills have to be run at 100% or else they lose money. But when it's like somebody's personal machine and they only know milling through like YouTube, they think that they need to be running their machine at 100%. But it's like, just slow it down a little bit. How much do I need to pay to get my name on the board? Well, we need to finish building the board. That's this thing back here. That board was an automated blue laser etching table. We'll get back to it. I've just been appropriately distracted. We had like 4 years of the boards running and doing their best. I am building in some stuff to water cool the board, to properly put everything together, to make it a nice presentation. And it's taken a lot of time, and it's taken a lot of burnout. And so I'm working on some audio projects because in the project queue for 20 years, I've told Julian that I would build him a synthesizer. So I decided to get into modular synthesizers and, you know, modular in general and audio. I haven't done a lot of stuff with analog. We mostly do, like, a lot of this is microcontrollers. That's a lot of what I do. But getting to know analog circuits and audio stuff has been an interesting journey. It's given me a lot of know-how in a lot of places that I didn't have it before. I knew RF, I knew microcontrollers. So in a deep audio pit. Yeah, I've been trying to dig down instead of dig angularly. What's up, Flatulent Gonad? I did watch that video, by the way. I watched the 3D printed wheel, which is kind of an insane, maybe waste of filament. But it proves out my point that you can run over a PETG print with your car and it'll be fine. That's how strong that stuff is. How good is your differential calculus? Unpracticed. Everything is unpracticed. It was a pretty stupid video. That was kind of cool, though. You know, people keep trying to make the rubber, the inflatable-less tire wheel, and it's very, very difficult to get the springiness that the inflated tire brings to the table. So they'll make the tweel, and they'll be like, look, this doesn't need, and then they're like, but dirt gets into it. And oh, my design is terrible, huh? I guess we'll shelf this one for 20 years and then bring it back out for a quick little anecdote. Orlin the Mage, what are you doing? 5 more gifted subs. This is like a personal sub train. Holy shit. Dude. They do good experiments on the Waterjet channel? That sounds interesting. I try to keep away from other makers' channels because then I end up like them. Like, I'll be like, call, blimey. I'll start bringing on an Australian accent and I'll make my cousin who sometimes gets into the chat cringe. My Australian cousin. I forget what city he's in. I'm a bad cousin. I don't remember a lot. My brain is just like a soup. I appreciate hardware. Too many software whores. You know, we try to do hardware here because hardware's a lot more fun. It's a lot more fun. You're in San Francisco. Oh yeah, home of software. We do get bogged down in software. We're going to be using AutoCAD today, so it's going to be sort of a fusion. That's the name of the CAD program. It'll be a fusion of software and hardware. Well, it'll be a fusion of software making hardware. So there's a little bit of programmy kind of stuff that we have to do at the beginning. We have to get our schematic down. I do hardware to avoid code as much as possible. Amen, brother. Although I not as much as Flatulent Gonad. If you just look at like game controller setups, you can tell the difference between myself and Flatulent Gonad. Flatulent Gonad has all of his game controller stuff built out of like wood, car parts, things like that. Like whatever he can get his hands on, he will build into his setup, and he will do it with analog. So as few microcontrollers as possible, you know, where you have a bunch of switches, maybe you need a microcontroller, but in the sense of like all the controls are just analog, and if you want to switch to a control, we'll just put that analog line on a switch. Whereas when I do it, I make sure that everything goes digital as soon as possible, and all that digital goes into sort of a nexus that I then program in order to do stuff just the way that I want it to. So there's a difference between the two different methodologies. One is that Flatulent Gonad actually gets stuff done. So Gonad got me making controllers. I blame him. It's so easy now. You just get a Teensy or like a Pico Pi, and you put a bunch of stuff into it, and then you literally tell your IDE, I want you to be a game controller. And it's like, okay, I could do that. That's it. Analog rules. Unfathomable. Putting an analog, like a control, like a potentiometer voltage level on a switch directly. I look at that and I go, ah, no, ooh, why would you do that? I gotta get a haircut. I'm not gonna be able to get a haircut until after the holiday. I'm like super mullet mode right now. Terrible. Oh, and in the Christmas card, both of my parents standing behind a chair, looking regal, very fine. I'm sitting in the chair with Willow on my lap, looking directly at the camera. Willow's looking at the camera. You can't take a bad picture of Willow. She's a corgi, fluffy corgi puppy. She's super cute. I'm sitting there and I look like this. I look high in the photo. It's terrible. Your hair is awesome. Nah, I don't know, man. It does need a little bit of quaffing. I need a switch to turn on an LED. Get a microprocessor. Honestly, like, listen, I've made the argument before, and I will make it again. The gatekeeping in electrical engine, like this kind of stuff, you know, making game controllers, making cool stuff, building things, just creating. Gatekeeping in it has no business. Like, gatekeepers can just fuck right off. Like, you smack people in the face if they gatekeep. If they go, oh, let's use an Arduino to blink an LED. Motherfucker, that project introduced somebody to the Arduino and how easy it is to write code that does stuff in the physical world. And maybe they're not an electrical engineer. Maybe they didn't spend their time getting made fun of and called no taste boy for listening to techno in high school. But maybe that one artist will bring something to the table that you've never seen before. Maybe they'll decide to put an interactive element into their art, and that will further just the pursuit of cool stuff. And that in and of itself is why your hand goes into the smacking configuration and graces your friend's face for being a fucking gatekeeper. So anyway, yeah, they called me no taste boy, and then they all went to the clubs and my music was playing there. Fuck you guys. High school kids in the early 2000s. Anyway, the point is the LED blinking, the classic, add an Arduino for blog cred. The thing is, like, the simple stuff is there in order to foster a foundation of knowledge that will bring you to higher heights. Are you winning, Bother? Comparing myself to high schoolers. No. No, I'm not winning. No, I'm not winning. Yeah, it's just, I can't stand it because it's like, the Arduino is used in everything, and it's such a great platform. And then you have people who are coming in here, and I'm not going to name names, but people who are like, yeah, use a 555. And it's like a 555 is an ancient little math device that is designed to frustrate. It's there for precision timing, but you need to do capacitor calculations in order to make something 555. And it's just like, yeah, you could do everything in a 555. Great, congratulations. But if you do something in an Arduino, you have a whole world of new creation ahead of you. Yeah, I fucking hate 555s. They're completely obsolete. You can just use an Arduino to flash an LED. It's fine. You don't have to worry about, like, logic. No need to stress over any code. There's you could barely even call it code in order to make timing go out of a microcontroller. You could barely call that code. There is a project that I would like to do at some point, and that's a logic drum machine. No software, it's only logic, but it's a sequencer drum machine that only uses 7400 series components. And I have to do an inventory to make sure that I have, because I've got a lot of TTL logic components in that case over there. And I would really like to make a that drum machine. It's a little bit different than the normal projects we do around here because it's like completely guided. We already have the schematic. Hardware is faster than software. Well, yeah, but our software is getting pretty goddamn good. This RP2040, well, the Teensy can run at 600 megahertz. What the heck? I know nothing like that holds a candle to like an FPGA, which is a sort of a hybrid software-hardware system. Because an FPGA, you put in the in, and that sort of squishes the poop out of the other end. It's like a toothpaste tube of functionality. But yeah, the Pi Picos, yeah, these are really nice because I'm an American. I'm in America, but I really want to say these are £5 just because it sounds cooler. We don't have that kind of nuance in our language. This is $5 for one of these things, right? 10 to the -9. What? Govna. It's fun to say. 390? Okay, well, that's just currency exchange. All right, here's the deal. We're going to start stream. Chat is active. Consider. I tried to turn that off, but I guess we can't turn that off. So you guys are just going to keep getting, like, poked, saying, chat's really active right now. Why don't you clip? It's like, bro, like one person. Because my chat dies because I do work here. It's not always exciting and fun. And so chat will die out and somebody will say, oh, it's cool what you're doing. One message comes up and then it goes, chat's really active right now. Consider clipping this moment. You're like, what the fuck? It works for larger channels. It doesn't work for us. All right, let's get this out of here. This is DJ Everyday. He's a buddy of mine. Oh, yeah, this is at District, apparently. Burning Man 2019. But yeah, DJ Everyday, he does sort of the deeper housey stuff. Will you dress up as Santa this year? No, I don't do that. I don't do that. I probably have everything I would need. I don't want to put shit in my beard. My beard is fine the way it is. Drum machine sounds like a fun project. Yeah, it's completely logic based. Why not? So there was, when I took the last vacation, I was sitting in line at the Philadelphia airport, and another Santa was like, oh, look at you, you're gonna dress up. And I'm like, I have a weight problem, motherfucker. I fucking hate you. He like immediately, I'm like, listen, I'm not gonna go gray. All right. Oh, I'm now here on the dark side. I'm not used to there being music. Yeah, if you're not hearing music, that means you're either watching the VOD or you're on YouTube. YouTube doesn't get the music. That way I can have my VOD archives and all that stuff just sort of automated. I do need to do thumbnails for YouTube. I'll need to sit down and do that. But right now I'm not getting my ADHD juice. And without my wonderful ADHD juice, these low dopamine tasks are very unfortunately hard to get to. I will get to making, you know, some emotes. We got to do a couple emotes. I got some good ideas for emotes squirreled away. And I need to do thumbnails for YouTube streams. I need to make like 5 or 6 of them, and then I can just alternate between them and have like a, you know, take a quick picture of the project that we're working on. Do you prefer digital gates versus analog circuits? I don't know the context of that question. That seems a little bit more complicated than what. Anyway, let me explain what we're doing now, because I've turned off start soon. Yeah, we got just normal AutoCAD stuff to do today. I am in fact sponsored by AutoCAD insofar as they simply allow me to use their software. They're allowing me to use the paid version of their software, which is something like $400 a month. And as long as I just every now and then I do AutoCAD ads. And it turns out we use their software so much anyway. I'm one of the few, if not the only, I think they keep correcting me on this, said I am the best. That's how we say it. I am their best Fusion 360 Eagle maker on their program. I'm the best. I'm the only one. But I'm also the best. That, you know, those are not mutually exclusive elements there. So anyway, the point is, as long as we use AutoCAD in our stream, that's it. That's all. And I don't even have to sing the praise of AutoCAD. I don't have to sit here and go, wow, this is the best software I've ever used. Now with such and such feature. No, they don't do that. They're just like, here, use their software. If you need to use, you know, KiCad or whatever else alongside of it, that's fine. They don't care. So anyway, yeah, I'm also the worst EE creator that they have. I have taken the leaderboard. They might recruit somebody else. I don't know. It's hard for me to keep up because they catch up with us on Thursday, and Thursday's when I stream. So it's hard for me to get in on their meetings and stuff. But anyway, so they're sponsoring my copy of their software. I would like to use it for some more generative stuff in the future. You know, some of those features, those wonderful features that I may have access to. Still jealous you got the full license. Yeah, it came along at a time when they actually required slightly more credentials to get the educational version of their software. Oops. And I don't know about the loophole about signing up for an online course at a community college, because I think that was one way that people were getting a copy of it, like an educational copy. Sign up for a educational course at a community college, and then they'll give you the free license and you just fail the course. Not sure how much I like Fusion 360 yet. I've been using FreeCAD and trying to switch for ease. So when you become an engineer, or if you fashion yourself in engineering, or you want to do engineering, you must become a jack of all trades. And that means going to whatever software is available to you at that job. And so you have to learn that software. Maybe they'll fund like a course so that you can actually learn, you know, like I've never used Altium. I've been meaning to learn Altium. And that involves pirating it, unfortunately, because you need the software in order to learn it. I could watch YouTube videos about it all day, but as an engineer, you should be comfortable with any piece of software that is required to do your job. And it's tough sometimes. They'll sit you down and go, yeah, we use CirCAD. And you're like, what the fuck is CirCAD? What the, huh? And you got to like learn how all the proclivities of that CAD program. I was using CirCAD for a long time to do the IED job. And that CirCAD is, you're able to make schematics fairly rapidly using intuitive, like PC is place component, that kind of thing. But yeah, anyway, I use Fusion 360 though. I've cut my teeth on AutoCAD in college. And then Eagle was the software that I would use to make PCBs for the longest time through many era of circuit creation. In this case, I'm using it out of convenience. I now know AutoCAD, I now know Eagle, and so those two coming together means that I can make a circuit board, render it into a very detailed 3D model, and then build 3D printed solids around it to my leisure. So our task right now, what we're trying to do, why do you like the op amp? I'm in the middle of something right now. I gotta explain to everybody what we're working on. Yeah, operational amplifiers are a necessary evil in sort of what we're doing here in analog circuitry. Julian wanted me to make a stereo mixer that's 2 channels, 2 eurorack units, which is an incredible restriction, and it would take 2 stereo channels. They would be normalized, so if only one channel's plugged in, it would put it on both right and left. If you plug both of them in, it separates them out. And then he wants volume control for the 2 channels that you're mixing, but then an overall volume control for a headphone style output. So we're using Thonky Kongs because that's just what you use. And then there's a stereo Thonky Kong that we're using for the output. And then these Alpine potentiometers that just have the sort of knurled surface on the outside, and they stick out just enough for one of these 2 eurorack modules. We're getting a little bit of inspiration from 2HP, but we're also kind of doing things our own way. 2HP makes... Okay, you guys didn't see that. 2HP makes these very small, they're basically all the 2 eurorack format modules. And we're not doing a horizontal circuit board. We're just doing one singular circuit board for this thing. So it's going to be a 4-layer circuit board because there's no way that I can get around that. And yeah, we're basically just sort of, I mean, this is a fairly common sort of form factor for these what you call it, for these eurorack modules now, because people have these portable modular synthesizer setups, and they want to minimize all of the components that go into it. They're in fact very flimsy, and that's because 2HP uses these surface mount headers. Surface mount headers simply are like your normal headers, except instead of the pin sticking down below it, it has the pin going horizontal out one end and then the other. And what people end up doing when they design for a PCB that has its surface mount headers is they just put a surface mount pad down and they put the header into that pad. And that completely ignores the fact that the header is what deals with the 10,000-pound gorilla in the room. When you have headers on stuff, and I don't know if I have good examples of that, the 10,000-pound gorilla is going to end up pressing against the sides of your headers, and you've got like unplugging forces on them and stuff like that. The FR4 bonding to the copper substrate is not necessarily going to be the strongest thing in the world. It would do you, if you're going to have something like that, it would do you well to put vias on those pads. The via will act like a little tiny rivet, and it will actually hold that pad in a little bit more strongerlier. But the problem is, like, these modular synthesizer guys, they do a bunch of PCP or Crocodile or whatever the fuck they're on, and then they end up having like a fucking mosh pit with all their modules. And then they come to me and they go, this broke, what happened? Fix it. And I have to go look at where that pad's going, and I have to put a little bond wire to wherever it goes and fix it up for them. And they go, you're a genius, you're so smart. And I'm like, guys, just stop breaking stuff. Please just stop breaking these things. Yeah, it's surface mount is not as strong as you think when you're dealing with a moment arm. When you're dealing with something that sticks out as a moment arm, it's not that strong. It just use through hole. What we're going to do is we're going to use through hole, but it's going to be a major pain in the ass because the through hole, I need to be flat on one side. So it'll barely even have a little nub from solder on one side. It'll still act as a rivet, and it'll still be plenty strong, but it just means that after I solder it, I have to do a bunch of finished touches to try to square it off and make it not interfere with the stuff on the other side of the board. But yeah, getting this stuff into Fusion makes it very pretty. You know, it looks very nice, and I can get an impression of what the circuit board is going to be like, at least initially. So that's why we're using Fusion 360. I think it's a very pretty program, and it's sort of what I know. We've had to find TLO74 op-amp equivalents, because the TLO74, while it's still an active part, they just never made a QFN package for it. I'm trying to... The challenge here is to go as small as possible, and that means that I need to rely on some technologies that I don't necessarily typically like to use. I like to use stuff that's a little bit more serviceable than a QFN. This is getting into the size delineation that really kind of presses you on stuff. I think one of the other things that could possibly go super duper wrong is our oval slots for the pins on these things. If there's any sort of discrepancy, we're going to have trouble fitting the pins in and then soldering them. Hopefully that doesn't become a huge deal. But again, in order to get enough space, I am going to need to crush these pins flatter to the potentiometer and even bend them a little bit to get under there. And I don't know if there's going to be that little bump out that they have in the 3D model. I don't know if that's going to be in the final part. The ones I have don't have those, so I don't know. Maybe we'll get around that. Just a bunch of stuff that I got to worry about. The reason we're going 4 layers on this PCB is that if I have an SO16, which the transconductance amplifier haven't been able to find an equivalent part that comes in quad flat no lead. If that was a quad flat no lead, we would be sitting pretty. We'd be having the time of our lives putting this circuit together. But instead, I need 2 of these transconductance amplifiers, one to do headphone volume and the other one to do the 4 channels of mixing on 2 separate controls. It actually trivializes having that sort of thing. I don't have to use a dual potentiometer, and I don't have to put audio directly into the potentiometers, because you can get a scratching effect if you do that. Instead, what we're doing is we are using the potentiometers as a control to make a voltage level, and that has to go through a buffer amplifier, which means more amplifiers on the board. But once we make that voltage level, we can just send it to whatever we want to control with that voltage level. So my right and left channel here have one singular control, and the 2 channels are in no way associated with one another. There's no like analog circuitry between them. They're isolated from one another. So they get the same control, but they're isolated. Then they mix together, which is literally just wiring them together. I'm always shocked about mixers. Mixers are weird. You expect there to be more like magic in a mixer, but in an audio, like an analog audio mixer, basically what happens, you have your input, you have some kind of a circuit that either adds or subtracts from it, or maybe equalizes it or something like that. And then you literally just put it onto a wire, and that wire goes all the way down the mixer for all the different channels that mix together. That's it. That's all it is. That's all a mixer is. It's just weird. But anyways, I don't know why I find that to be weird in and of itself, but it's just a weird thing. So anyway, we mix our rights and our lefts, and that gives us our big right and left here. And then we do the volume control using another transconductance amplifier. I would minimize this as much as possible if I could. I was thinking about it. I'm like, why do I need... No, I need all of it. I need all of it because of the way things cross over in this. Very annoying. So I need 2 of these SO16 chips. We looked on, what are they called again? Cabin Tech. We looked on Cabin Tech. I don't think Cabin Tech carries the any smaller packaging of these chips. And I don't know where I would source it from, because DigiKey certainly does not have anything like that. That's why we go to places like Cabin Tech. I know there's a Euro equivalent of Cabin Tech. I don't know what it is, though. But yeah, so anyway, I can't find it in any smaller of a package, so this is a big sticking point. We have a big SO part that goes into this. From that mix, once we mix the left and right channels and we have them come out in their sort of volume control mode, we then turn the current into voltage. A big component of this is you turn voltage... Oops, wait, put that back. You turn voltage into current, and so now everything is current controlled, and I guess that makes their design more easy or something like that. I don't know. I don't know why you go over to current domain, but once we're in current domain, we stay in current domain through the volume control, and then we output to this operational amplifier circuit that inverts. So our initial op-amp, our buffer op-amp, this is here simply to protect the rest of our circuit. It's there so that no matter what you're putting into it, This thing is high Z. It does, okay, give me that frame back. It doesn't really mess around with anything else going on, and it, going in rather. It just ensures that my friends don't accidentally blow up my circuit. I really hope they're not capable of blowing up my circuit, because this is a fair bit of complexity. This is another expensive op amp that I have to include with everything else. I'm putting that in there just simply to keep Julian and Dave from blowing my shit up. What's up, Groovy? How you doing? So anyway, we've got that, and that inverts the signal. So if we were to have something going through this mixer and then something that's not going through this mixer going into another mixer, they could potentially have weird effects on one another. I'm sure they will find a way to blow it up. There's significant overlap between the things that will blow up my circuit and the things that I'm not considering. So yeah, we invert it, or rather this inverts it again. So actually coming out of here, our signal is in phase with itself, which is great. But since I have 2 leftover op amps, because they come in quads, I could get a dual op amp on this, but that means I need to order different parts and stuff. So I've got 3 op amps up here, and one of them is parked, unfortunately. And then I have this mirrored circuit that uses, god damn it, that uses another 8. So each of these mixing circuits in its minimal-ish form, I mean, I could do 7 and 7, but still I'd have, whatever. Anyway, if I just order one part for all this stuff, I can throw in a bunch of the same IC, and I have this extra channel here that I can use to revert the signal and turn it in, or sorry, invert the signal again. And that way I have a differential signal that I can put into the part that we're going to make right now. We need to make one more part. We need one more part. So that would be the audio amplifier. I don't know a thing or two about headphones. I know a little bit about headphones, but I don't know a thing or two about headphones. And so, you guys didn't see that. So we're using an actual headphone amplifier, a stereo hi-fi headphone driver. This is because I'm dumb. That's why we're using this. What does this bring to the table? I have some loose justifications about it, filtering transients and doing some other headphoney stuff that I don't understand. That's it. That's all I know. So my assumption is that we are taking this out to professional audio levels, which is 1.7-ish volts. And that can, of course, be adjusted to on the amplifier. But we have a differential coming in over here, and we simply just punch that into this chip, and this chip gives us what we need on the output. That's my assumption here. I don't know if I need to worry about anything else. Output voltage noise 9 microvolts RMS, blah 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 blah. So that's what I decided to do. You didn't see that. No, you didn't see that. But this is a weird part. This is a weird part. And so we need to make the weird part. Here's the layout of the pins, but we need the physical dimensions of this thing. Because we're going to punch these into AutoCAD, and it's going to generate the part, and then that'll be that. It'll be nice and easy to use. Down we go, down, down, down. Down, down, down. Okay, so here is her part, and we can just punch these dimensions into our program, and it'll auto-generate. What is all this stuff? Thermal information. We don't need that. Now that's the pads. I think we're not worried about the pads. We look at the physical chip itself. Usually these would be in like a table, like this. Oh, that's not that. But yeah, we'll just get them off of this drawing. Third rule of about. Okay, so we need to actually make a part. So what I need to do is open up my parts library, and that's from the, you can get there from the, what is it, the place components dialog. This is Jesse 2018. I always name the year wrong on my parts. I need to go through these again and like make a new library, the Jesse 2020 or something like that, where I can get all of my really good parts, but the ones with 3D models, and sort of, refine them a bit. The thing about your own parts list, your own library, is that those are parts that you have used and you've refined and you've made sure that they work from the board manufacturer. Having that sort of personal library enables you to be confident in ordering a board. And that's, that's not as important anymore because boards are like $5 for like 10 of them. The cheapness of getting a full-blown PCB manufactured has completely pulled the carpet out from my design process. It used to be that you would start with the solderless breadboard because that's immediately reconfigurable. You would then go to perforated prototyping board where you would build a more permanent design, and sometimes that's where the project would stop because you just need one of these things. But now you go from perforated prototyping board to CAD. Well, you would go in the past from the perforated prototyping board to an initial design of the PCB. You then make sure that the PCB works, do a second run, and you're out like $200, and you have a nice professional circuit board to build your stuff on. But with $5 circuit boards means you can go directly from the solderless breadboard to a PCB design. That's what we're doing right now. I'm not going to solder this more permanently to a board because I can just get a board made for super duper cheapos like these, like the VCO circuit. Like, we just took a design from Hajiwo and just kind of put stuff together in order to make a PCB. Bob's your uncle, right? Like, you can look at it in 3D in the CAD design, and you could just get, there's literally a pull-down menu where I can output the files needed to make the board. So anyway, we need to make a part. I know these libraries. This is my chips library. I can open the library manager. Oh, actually, that's maybe not what I should do. Well, whatever, in use. Click on in use. I only use my own libraries. If I need to pull something in from an external library, I will enable that external library, but then I'll transfer the part over to mine before I end up using it. So chips managed, I actually want to edit. Edit chips managed, and that's going to open it up in your library editor, which is another tab, and it's another bunch of stuff coming in from the sides. We can look at the various parts that we have in terms of like the schematic symbol and then the packaging and stuff. They're all stored in this little tree. And so you've got a tree that has the schematic symbol, and then it has the two-dimensional part, and attached to that is a three-dimensional part. So we are doing a new part, and our package is sort of this QFN. It's sort of a decently common QFN. Unfortunately, when I bought breakout boards, I didn't have 5-pin. Mine are 4-pin. I'm gonna double check that. Let me just take a look at one of these on the microscope. One of these days we'll do a gaming stream. I promise, chat. I promise I'll do a gaming stream one of these days. It's just this project has been burning a hole in my ass. Yeah, see, these are only 4-pin. This would be the appropriate spacing for the other one, but they're only 4 pins. Whereas the chip that we're putting in is 5-pin. And so in order to do that, and again, this is hearkening towards the old school skills that are still very much relevant in electrical engineering, and that's holding your hand very steady and soldering little wires to things. When you use these cursed, tiny surface mount packages, you have to do something crazy like this every now and then. Yeah, I don't know why there are freaking bullet holes on the... This is just what was on Amazon and that I could get fast enough, but they put a bunch of like bullet holes in it. I think they're supposed to be stars, but I really wish they didn't have that personal flair, because it really kind of messes with you when you look at it. And also, it's like, which pin is pin 1? Is it this one? Is it this one? Wait, which one is pin 1? I mean, you can see by the circuit traces that pin 1 is over here, but with the big explosion. I just ordered a 1206 book after years of watching how you do stuff. 1206, I think, is a little prohibitively large for me. 0603 is where I'm comfortable. 0805 is what's good for 0.1 inch spaced like perf boards. 0805 is where I generally operate, but in this case, like if I'm building something that I want other people to be able to service, 0805 is really where I go. 1206 is very kind. It's a very kind size to use. But 0603 is the limit for smallness of my soldering ability. I can do 0406. We might be forced to go to 0406 on this design, but I lose 0602 too easily. Yeah, I mean, it's all down to, and again, like a lot of what I teach here is like steadying your hands, getting that wrist down on a surface, you know, bring the circuit board up a little bit, and then you can have very precise control even if your arms are shaking. Nice. What are you building on that? Thanks for the input on the power supply input for the Photon SE. Oh yeah, they figured that out, didn't they? I wasn't able to really get very far with that. I just had that one suggestion in passing. I've been a little busy lately So I'm glad you found out the power supply for that thing. Goop printing is a very interesting thing. Scared of struggling with the small ones. Unless you've got like a really good microscope setup. Yeah, the microscope, when you go to 0406, oh, hold on, wait, I'm gonna cough. Oh, no, I couldn't mute it. What's wrong with my Stream Deck froze? Hold on. Doing Pi Pico stuff. I really want to do that keyboard project. Bring my keyboard takeover to a flexible orange PCB still with a Pico Pi, because I mean you can't. These are like $5. Like, come on, man. What I want is an orange PCB that I can solder this to, solder the Maxim chips to, and then it'll have a little square opening on it where I can take over the IC that controls the keyboard. And then I'd be able to have a full keyboard takeover with this thing. That'd be really, really cool. We'll work on that soon, because my spare keyboard has been dead. Listen, I didn't engineer. The Code 10 keyless keyboard is a really good keyboard, right? Code 10 keyless with cherry clears. That's what I use. I love it. They decided to put the microcontroller very low on the PCB. With the microcontroller around the space between the arrow keys and the whatever they are, delete and stuff, the microcontroller's fairly low on that tilted frame. And so when I'm gesticulating at my desk and I go, what the hell? And I knock over my whiskey and it goes all over the keyboard, that gets into the microcontroller and it just goes, ah, and then dies. That's it. It just dead immediately. It explodes. I'm guessing that it probably gets into the clock and messes up the clock, because clocks need a little bit of air. For some reason, the quartz crystal in them or something needs some kind of an even air exchange. But the microcontroller gets really drunk and then dies. Falls into a coma. So what I did is hand solder in a Pico Pi and use QMK to take over the keyboard. That keyboard's been running great for a while now. And so what I'd like to do is turn that into less of a wire affair and more of just a solder the thing in affair. And I think it'll be really nice. But yeah, anyway, we got all this stuff going on. Let's get this part in here. So this is going to be a quad flat no lead. But yeah, I'm glad to hear about your projects, Chester. I'm glad you're making progress and that I influenced somebody to do something. It's weird. I've been doing things kind of my own way for a long time, and my own way is starting to become other people's way, just by virtue of the fact that I'm broadcasting my projects. It's an interesting thing. It's a little bit of an existential crisis, isn't it? Okay, so we don't have any part like this. This is a headphone amplifier. I mean, for all intents and purposes, I could just put in something like a TL07-2 and modify that, but I think what we're going to need to do is just make this from scratch. It's very easy to make these fully 3D realized parts from scratch in AutoCAD. It's pretty easy to do. Oh, bother's influencing me. I really want a corgi. Listen, Willow's the cutest, bestest dog in the whole world. That's it. That's the whole thing. I didn't have anything else to say. That was it. That's all I had to say. That's just that. Okay, so new part. So we're going to start over here from the overall parts diagram. And actually, we don't necessarily have to do that yet. We could start with the schematic symbol first, but we might as well just make this thing from scratch from here. So this is a new component. This is a new entry in the component library, a new tree that we have to make all of the different pieces of. So what we're going to call this is, engineers are extremely creative. And so we're going to come up with a snappy title for this thing. We're going to call it DWP0020B. Oh no, TPA6120A2. Don't ask me how I made that up, but it's a pretty cool name, isn't it? It's like naming monitors. Like, why can't they call it like the Leopard 4? Why do they have to just like bash on the number pad? You got a fucking name for one of Elon Musk's kids suddenly. So the TPA6120A2 is apparently what this chip is. We're going to make that, and that's just going to make a big empty entry in the tree. So what we need is a schematic symbol to put into this right here. The schematic symbols and the footprints and the 3D designs are all kept in their own little categories here. They've got their own little listings. So what we do is we make the part, and then we open up the overall part and associate the parts that we made with this device. So we put the entries into this framework here, and that's going to define what footprints connect to what pins. That's sort of the purpose of what we've just done. So this is just a placeholder. Well, not really. This is going to be the part. This is going to be the part, but it's empty. But first, we need to actually make the footprints and stuff. Now, this would be facilitated very easily if we were adding a part that is a standardized part. If I wanted to add an op amp that is similar to the TL074 and has the same SOIC footprint as other op amps that I've already put in, this is trivial. We just do new local package, and then we can just say, oh, it's got this package here, and here's what pins are connected to what. The system works really well when you scale it and when you understand exactly what's going on. It took me a while to kind of get a handle of this in relation to also editing 3D parts. There's a whole thing. And if you're doing 3D parts, you can actually download from somewhere like GrabCAD or directly from the manufacturer. You can get the 3D model and then associate a 3D model with the pads. What we're going to do is we're going to make a two-dimensional part, and that'll define where the pads are. That allows us to make a standardized three-dimensional part, but then we have to go back into the two-dimensional part and delete the pads that aren't there. Does it have a 14 QFN? It does, but we don't need all the pads of a 14 QFN, and I don't want to have no connects just hanging out on the board. Because we need every circuit pathway that we can get. So I'm going to make my own. I don't think I already have a QFN. I have a 28. Oh, these don't have 3D models. Huh. That's a Vicor flat pack. Yeah, we got some cursed things. But I don't think we have... These are some old models. Wow. The new ones you can tell because they've got that sort of high contrast black on them. Got red on you. I have not done a lot with QFNs. Oh, here, these are from the RC car project. These are desperately tiny. They're really annoying. These are absolutely tiny. That one's a 4x4. 4x4. Oh, God. That one is actually the two op amp equivalent of what we're sort of putting in. Sorry, of what I've already got in there. What's that one? Yeah, 4x4. So yeah, we don't have this already. So we're going to do well, first of all, let's do the schematic symbol. So we're going up here. Do you use hot air on QFN? Yeah, I use hot air. I do have an oven. I actually do have an oven. I have several, actually. Toaster oven is one of the better ones. You can go to a yard sale and get a toaster oven, and then you can buy, I don't know how much they are these days. You can buy a kit that basically is just a microcontroller and a thermistor and like a solid state relay, and then that controls your oven and brings it up to the solder profile. You can also get a skillet, and I think that's what we're going to use for these. For these, to solder these, we're probably going to be using a skillet and solder paste. I don't think I'm going to get a stencil for these, but we can just put a little tiny line of solder paste down, and we can put it on top of this extremely dangerous skillet, which is basically just an open burner in the shop. If I slip and fall, I might get a square burn on the side of my face. All right, so what is this symbol? Well, this is going to be the TPA 6120. It's kind of a unique device. We're going to have a couple different designs on this thing. So actually, this is the TPA 6120. We're also going to have the TPA 6120 extra pins, I guess. The 3D printing, I've seen a 3D print farm that humidity is really important. Their print quality looked really nice. Yeah, things like PETG will actually wick moisture out of the air and end up swelling a little bit, and then you get really bad prints out of it. The PETG I use, though, has been perfectly fine, and I've got it sitting beneath a window. So I'm guessing too much because printing problems. Everybody will point you towards moisture. Everybody will point you towards too high of temperatures. With my experience with PETG, I simply raise the temperature. Every time I raise the temperature, and it just works now. But again, like, there are guides that you can follow that will really help you get your prints running properly. I am not as good as a guide. All right, so their symbol, they just throw this in there as an amplifier. I thought I saw a more fun symbol for this thing. Take a look here. Yeah, they're just an amplifier. All right, so we're just gonna use an amplifier schematic symbol. I was hoping we would do something a little cooler than that. There was like this flat front amplifier that I thought they drew it as, but I guess not. All right, so yeah, we already have a symbol for this, but it's a little bit different because we need a right and left power. So what I'll end up doing, yeah, we don't actually need to make the schematic symbol. We don't need to make it. So we don't need this. So we're actually going to jump back out and delete the thing that we just made. So we're going to go to the, oh God, what was our part number again? TPA 6120. ABC, PQRST. TPL. TPA 6120A2. There we go. I'm going to open that up, and that's going to close the schematic symbol. And then I'm going to go to the TPA 6120 here. Oh, did we not even save? No, there it is. And hopefully this is not being used. Okay, good. Yeah, it wasn't being used. All right, so now we need to open this up again because it closed. TPA 6120, and then we are going to go into the device tab, go to, what is this called? Add. And now we're going to grab an op amp. So if it's under the TL074 op amp, there we go. So we're going to add 2 op amps. So we'll put this one on 0. Boom. Boom. And then I'm going to add 2 power supplies because that's how this chip works. So I'm going to go back to add. I guess I have to escape out of it. Go back to add, and now we need, where is that? It's power plus minus. And I add 2 of them. Actually, I could do it like this. Yeah, maybe we'll do it like that. Give that a little space, move that back in here, and there we go. I mean, I guess I could probably rename these. They're both called power 0. And then add next swap equals 0. I guess I'm going to leave that in. When you have the swap level, what happens is you place a component, and then you place the other part of the component, and then you place the other part, and then you place the other part. With the TPA 6120, we've got 2 separated channels of functionality here. We're currently at 400 degrees Celsius. What? Doing what? So how do I handle no connects? I think I have a thing for no connect. I think so. So that's our schematic symbol. I think that's all there is to this. Let's double check. Circle back, double check. What ins and outs does this thing have? Oh, I guess that's this symbol down here. Doot, 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 doot. Okay, yeah, so that's it. It's just left in, left out, right in, right out. I really would like to rename these pins. Can I rename these pins? No, I can't. I would have to make my own pins in order for them to be defined like that. Oh, whoops, hold on. U1R. U1L. Let's see if we can rename the power. PR. That'll help us organize the pins. PL. So we're naming them right and left so that we know what pins go where, we know what we're hooking up. Are you religious about the kind of diodes that you put on power input? Schottkys are the ones to use, says my research so far. The reason that you use specifically Schottky diodes is they have a very low voltage drop. Very low voltage drop. They just let everything in. without affecting it on the other end. Now, if you're doing like a 3.3 volt system on a eurorack, you've got 12 volts. Who cares? Like, who cares if you've got Schottky diodes on the in and out, then you're dropping up to like a volt, right? 7 and 7 is 14, 1.4 volts. That's 1.5 volts in a system that's using analog voltages. It doesn't really matter that much. But if you want to have a minimal incursion on your voltage level coming in, then Schottky's the way to go. Again, eurorack, we've got 12 volts running around. We've got all the voltage we'll ever need. So it all depends on what you're comfortable with putting in there. And then also considering if the voltage drop is that high, how much is the diode going to be converting things into heat? I don't think Schottky diodes are particularly cooler than a regular old switching, like a 1N4148. But you know, hey, maybe it's getting a little toasty there. Because what's happening internally in the diode is it's actually making infrared light. That's why there's the big can around the diode. I don't know about the glass-covered diodes. Can you see those on a camera producing infrared? I heard that all diodes produce infrared to some degree. Maybe I'm wrong about that. All right, so we've coded these as R and L. So that'll help us out immensely when it comes to putting the pins together. We now need a footprint and a 3D model. We don't have to use Library I/O to do that. Library I/O is just an online interface for what we've already got within Fusion 360. It's confusing that both exist, but this is another instance of AutoCAD or Autodesk or Auto whatever buying up a company and then just stapling it to the side of their program. Library I/O was a way to keep all of your components, symbols, and 3D models together and share them, but I think they like turned off the sharing thing. So we're just going to make it personally. So what I'm going to do is I'm going to stay inside of this program and not go online with it. This is still online, by the way. Welcome to the permanently connected future, where every single click is probably logged. Anyway, we're going to add a local package. Or no, we're not going to do that. Cancel. We're actually going to go up here and we're going to do new 2D part. And this is going to be our part number, TPA 6120A2. Remember, this is on a different list, so it's not going to collide with our other naming. So we make that new 2D part. And I think I messed up. Wait a minute, I don't want this at all. This is going to make its own package if I do it in that. Or do I do... No, I think we jump directly to the 3D model. Yeah, let me delete this. Or I need to open up something else to delete it. Sorry, I did the wrong order of operations. It's a cardinal sin. So back to 2D pads, and we're going to delete this one. I could attach a 3D model. Wait a minute. Create new 3D model for this pad, even though I don't have any pads down. Is that going to place pads, or am I out of line? I got to think about that one. Let's see. Let's just start a new 3D part. And then that gives us our package generator dialog over here. And so we're going to be generating a QFN. So we just choose it on the list. And now we've got a dimension dialog. So we're going to throw all these things in there, and that'll auto-generate our footprint and our spacing and all that stuff. Yeah, so I guess you kind of skip the 2D package part of it and go directly to the 3D package. And then when the 3D package goes in, it'll auto-generate its pads. Okay, so I am going to go to this datasheet. And we're going to go down to our mechanical properties, which are typically at the bottom of the datasheet. And then you've got like legal stuff at the very end. But you've got like the package that comes in the mail, the real dimensions. What are these? These are order information. Oh, packaging information. Okay. And then above that, you've got your actual footprint and physical chip layout stuff. So we're going to the physical chip, and we're going to rely on Fusion to auto-create the pads. So now we give it all this stuff. So pins on D and E side, that's going to be 5 and 5, 5 by 5. Pad shape, I'm going to go with oblong. That's sort of the traditional one. E, little e. What do they define little e as? Now, here's the thing. There's no strict standardization in these dimensions. People generally follow somewhat of a standardization, but if you're using like a weird part, sometimes they'll define stuff with different letters and stuff, and you got to be careful about that. So what they're asking for in this window may differ from what we find on the datasheet. We need to process what each thing is. Little e is the space between the pins. So little e, space between the centers of the pins, that is 0,50. Listen, for all of the wonders of the European system of writing down like metric stuff and having it be divisible by an easy number, using a comma as a period is one of the weirdest fucking things I run into. Why do they do that? There could easily be confusion about like big weird numbers if you're using commas instead of periods. Why would you do that? It's the same thing with like 4R7, which is 4.7 ohms. 4R7. So I don't want to put a decimal there. I'm going to put R in the middle of it. Why are they using commas? If we're dealing with numbers that have a bunch of digits, you're supposed to comma every 3 digits. So if you have a number that's like, it's like 2, 0, 0, 0, 0, 0. That's 2000.00. But I've only used commas. Anyway, so we're 0.5. 2.00. They just switch them for nothing? I don't know. What? If AI does it, we'll be able to continue to do it. Where's the fun? What? Engineering will be easier when AI can auto-generate these parts from the data sheets. Yeah, I don't know. I mean, I guess that would be nice. You definitely have to make sure that things are going in correctly, though. And one of the biggest problems is when mechanical engineers are doing dimensions, they leave out fucking everything because they're like, you can derive that from this and this and this. So sometimes we have to actually like go in and reverse engineer some of the dimensions on the part. Like, bitch, you know you're going to be putting that thing into something that's asking for these specific parameters. Just give us this stuff. Sprechen Sie Deutsch? No. Unfortunately, no. I didn't learn German language. I should have. My high school had a course. I should have taken it. I took Latin for all the fucking good that does me. So anyway, 0.5 on that one. So now we've got our min and max dimensions, and these will the min and max dimensions only really come up when you actually want to do map silkscreen to body, maximum, normal, and minimum. But for the purposes of putting this thing in correctly, we're going to make sure that we get all the individual dimensions correct. So big L. Big L is edge of the chip to the first pin thing. Edge of the chip to the first pin. Well, big L is going to probably be a little bit different for these two than these 4. That's the problem with this specific part. We're going to have to go in and actually edit the footprints on the 2 sides. Right now, we're going to make a symmetrical chip. So I guess we're going to ignore the 1.5 dimension here. So our distance to the edge, is that what big L is? Oh no, big L is the size of this pin here. It's the length of that pin. So big L, we're just going to make the same, I guess it's the same all around? Well, they don't give us a big L for that side. What do you guys got? What's the pad size? 0.8 for the pad. But that's way bigger than the pin. I think we're just dealing with, 14 by 0.5. Okay. So 0.5 max, 0.3 minimum. Oh, that's already what's in here. Little b. What up, little b? Little b is the width of the pin itself. 14 by 0.3 to 0.18. 1.8 rather. 0.3, and then this one is 0.18. Oh, nice. You got a ham radio operator. Tell that to Fatanon. He's been doing ham radio stuff lately. I think he got all the way to Japan with a broadcast. Kind of thing makes me double take, but Yeah, I mean, look, it's not, I'm not saying it's like a deal breaker. I'm not saying it's literally befuddling me, because I know a lot of European people like to be like, haha, Americans so stupid. Look at this guy. He's literally paralyzed when he sees a comma instead of a period. It's like, no, it's just inconvenient. It's just a little bit less clear than things could be. You always see that. It's like a thing that the internet likes to do. Everybody likes to like, oh, blah 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 got slammed by blah blah blah, and then the actual, when you read about it, they're just like, I don't prefer that. It's like, oh, okay, that's apparently what constitutes slamming these days. People are slamming America about this thing that they do. Whatever. Big D. Big D is the overall distance, and so that's 3.65 to 3.35. So 3.5, oops, 5, and then this one's 3.65. Big E. Our Big E is the other one, so it's going to be the same thing. .65. The cool thing about AutoCAD is you can put this in millimeter or inches. So if I specify, it will put in an inch dimension if I really need it to. If I don't specify, then it's going to put it in millimeters. That's just my default settings. Big A. Big A is the width of the chip. And I guess we don't do standoff from board anymore. So Big A is, the biggest size of Big A is 1. Ah, and that's what we got anyway. Map silkscreen to body for the maximum dimensions. Oblong pads, 5 and 5. We could specify footprints in the thermal. I guess we do need to put in the thermal, because this is important. This thing needs to be able to bleed out heat. So the thermal pad dimensions are given to us here as just a distance. 2.05 plus minus 0.1. I guess we're just going to give it as the nominal, which is 2.05. Thermal pad, yes. 2.05. Boop. Boop. Custom solder paste. Huh. Do we need to customize the solder paste? We've got all the information for the solder paste. I think no. I think no custom solder paste. We'll just leave that at what it thinks the default should be. Don't listen to the SI elitists. In SI, if you use newtons for force and millimeter for length, your standard of unit density is tons per millimeter cubed. That sounds cursed. I'm glad I don't do mechanical stuff. Kilograms per meter cubed. Oh my God. They're all trash, all of them. 3/3 of 129. Okay. All right, so yeah, that's it for this. We're just going to add that part, and it's going to do a little bit of calculating, a little bit of automation down there. Bada bing. There is our part. It's got the labels for the name and value. It has all of the pins, and apparently cursed thermals. How do I edit that? How do I edit it? I guess Control Z. The library IO is easier to... What if I double click on that? Oh, there we go. Okay, we can edit it here. Thermal. Oh, 2.5 by 3.5. Whoopsie daisy. 2.5 by 2.5. Oh, and it's actually not 0.5. It's 0.5. 2.05. Look at that. We can make mistakes. We can make mistakes, and we can keep going. You have to keep going. 2.05. Update. Ding. I should make a little ding noise when it's done. Ding, pressure done. Okay, so that's that. There's still some editing that I want to do to this. So I'm going to hit save. Because we've got a custom weirdo pin spacing on this side. Actually, wait a minute. Maybe we can edit this and make it do the 2 pins on the sides. Because when we're talking about... No, they only do 1 pin spacing. I was thinking that we could do a different pin spacing on the sides, but I guess we're just going to have to delete stuff. because we've got the 5 pins on the top and the bottom, but the other pins are actually just not there. And then they have a separate spacing. So we'll be able to go into this model and actually edit it as a normal solid. Hopefully we'll edit as a normal solid. These are just kind of pressed into place, right? Yeah. If these are just kind of pressed into place, hopefully that means that I can sort of scooch them over. So let's go into the package. So saving this, and then, oh, hit finish part. That's right. The thermal pads get soldered to the ground plane. It depends on what they recommend. Thermal information. Junction to ambient, blah, 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 blah. Nope, more stuff. I need So thermal pad, they will specify, they'll tell you what to do with it. Connect to ground. In the case of the op amps, you actually connect the thermal pad to negative voltage, not ground. I think we should have a thermal pad that connects all the pins. I am convinced that this will be effective. Yes, we will short it out. It'll become a brick. The thermal pad must be soldered down in all applications to properly secure the device on the PCB. Moreover, this thing gets warm. This thing actually gets the warmest of any of the other components. So, but in this case, yeah, they'll tell you what to do with that pad because you don't know. Sometimes they leave it floating. You know, other times it'll be, again, like the example here is perfect. Sometimes they say, hook it up to negative, which is vastly different from ground in our case, because we are referencing everything on a ground that is the mid-level between 0 to 24 volts. So we have negative 12, positive 12. And that gets confusing, but it's literally just whatever you call it. This is why Ben Franklin got away with calling positive negative, and we've had to deal with the repercussions of that ever since in electrical engineering. You need to break out of your propensity to believe that 0 is nothing. 0 is, in fact, whatever the hell we define it as, and everything is referenced off of zeros because electrical engineering is all about potential. It's all about all the potential that you're squandering as a human being. You can do better. So, in this case, we connect it to ground. So we will indeed define the thermal pad as connected to ground. If we go back to our device, we can assign the pins now, but we need to do some custom stuff with this thing. I'm sorry. So we've got our schematic symbols in here. We don't have our component yet. We need to go in and actually edit this component. So I'm going to go to the 3D, well, actually, no, the 2D component, and I'm going to find the thing that we just made. They really do give it a cursed fucking name, don't they? They just name it whatever the hell they want to. I hate that that happens. And that's got the 3D package associated with it. But we want to edit this in the 2D thing. So we go to the 2D thing. Oh boy, here we go. So pin 1 is there. We need to make sure that we're doing it correctly. It's not going to be in the same layout as it shows in the data sheet necessarily. So pin, oh boy, where the fuck is pin 1? Oh, pin 1. Oh, I see. Okay, so 1 and 14, 8 and 7. What the? This says top view, but it's the pins are defined differently. The naming department of any hardware company is always run by a group of cats who fancy keyboard walking. I mean, it makes some sense in the way that it's naming them. It called it QFN and then had a bunch of information about the dimensions, which is a little bit over the top. I'm changing my name to Max Squandering. What's up, 3D Printer Shack? How you doing? All right, how am I going to go about doing this? This is kind of crazy. So it's going to be 1 and 14. Well, let's go look at the bottom of the chip. And this is a symmetrical chip, so we should at least be able to... This is going to be a lot of weird rearranging that we have to do in order to get this thing to work properly. This is why I saved this for today. We were going to get to PCB layout, but it's going to take us enough effort. It's going to take half of the stream in order for me to figure this thing out. So this is the view from above? No, this is the bottom view. So this is what the chip flipped. Yeah, it's just a weird numbering scheme, huh? Wait, then why is it... Huh? This is just literally counting in the opposite direction that I think it should. Where's our top view? So this is looking through the chip. So let's make this pin 100. And then that frees up pin 1. And so we can rename this one pin 1. And actually, let's get rid of these. We're going to trust the data sheet. So we've got our initial layout, and then the location of these pins. These are going to be how far from, where's center on this? Oh, center's in the center. You love it when you see it. You love it when you see it. It's very nice. All the way down to the bottom. And we're going to look at the spacing. So the spacing of these guys, 1.5, which means this is going to be in location, blah, 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 blah. 1.6 becomes 1.5. Not 15. Wait, negative 1 point blah, blah, blah. This is at 1.5? Oh, no, it's 1.5 between the two. So it's 0.75. So instead of 1, this is 0.75. Similarly, this one is 0.75. And then this one. Why do I know that? Because of the English units of measurement. Why is he so good with fractions like that? Because quarters. That's how you count quarters. 25 cents, 50 cents, 75 cents, $1. Eat that, metric brains. The European mind can't even comprehend that. What just happened? Ooh, put the legs on the keyboard down. But get the wire that's under the keyboard out from under the keyboard, because it's causing your keyboard to wobble. Ah, and the bolt, the maker beam bolt that's under your keyboard. Get that out from under there too. My keyboard was sitting on a maker beam bolt and a piece of wire. That's how these places are organized. Okay, so now we just renumber these guys. The only mental arithmetic I can do is the first few powers of 2 because I have them memorized. So here's a trick. Here's a trick in both life and engineering. Anything after 3.141592, you can just make up. And if somebody challenges you on, you call them the bigger nerd. Ah, you fucking nerd. How'd you know that? That's it. That's all you need to know, and it makes you look infinitely smart. I know pi. And a lot of the times I see in engineering, they just call pi 3. It's just 3. It doesn't matter. All right, so and we're looking for pin 1 as we look down at the pad. So make this one pin 1. Pin number 1. This one 14. Which we already have on the field, so... Oh, no, I deleted 14. One 14, and then this one's 13, which we probably... 13, 12, 11, 10, 9. Oh, how am I going to do this in an order that doesn't... 8 and 7 are already there, so we might as well go through here and do 2, and then it'll just sort of steamroll it. This one's been 3. And number 4. Number 5. We're just going to go around like that. I don't know why this one seems to do it the opposite way that the CAD program assumed it would. Which is, the problem is that's confusing me. Because in the past, and again, why is Bother so adamant about his surface mount technology is because I hate the spatial confusion of when you flip sides of the board back and forth. I feel it's common experience to be in calculus final, plug in algebra into your calculator. Yeah. I actually, the reason that I passed with control systems is that I learned how to program matrix algebra into the calculator. It was more of a programming final than anything else. On the ever so ubiquitous TI-98, everybody's got it. Of course you use that in industry. I have my TI calculator sitting on the shelf over there. Let the chips do what they're good at. Yeah, right? Get me out of the equation because I'm where all the errors happen. I am the source of 90% of the errors in this crap. Pin 8. Nine. 10. 11. 12. And then 13. This one can be 14. There we go. Pin 14 already exists. Challenge. Oh, 15. All right, there we go. Pebcac, yeah. The problem was you had to program all the matrices in that weird TI way, using the brackets and parentheses and the commas. It's a common programming thing, but it was still very difficult to do while all the pressure was on you during a test and you had to enter it using the weird TI keyboard. It was a trip. That calculator was amazing. Absolutely amazing in making it so that I didn't have to think about what the fucking eigenvalue is. What is an eigenvalue? I don't care. Okay, so there's our new layout. It's a little bit crazy. It's a little bit cursed, but we're going to save that. Click OK. And now we need to edit this 3D model. So we're going to open this up, and that's opening it up in traditional AutoCAD windows. So now what we can do is get rid of all the superfluous pins, and we can arrange the pins to actually be on the right spot. Now, doing that is entirely a visual thing. Whoa, 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 what's going on here? It does not matter that we have these pins here. For the purposes of our mechanical design, oh, please don't crash on me. Please don't crash. No, you're not allowed to crash. Oh boy. I hit save, right? That was, you saw me, I hit save. That better have saved. There isn't a little asterisk by it, so I think I did save. Come on, you can make it. Oh my God. You can do it. Pull through. Objective survive. Oh, I think it's properly hosed. This one, the 3D model has an asterisk, but the library does not. Hashtag AutoCAD ad. Hey, they didn't tell me to sing praises. They told me to evaluate it honestly. They actually said that. They said, you know, you don't have to sing the praises. So, AutoCAD. My dog is napping right now. She's upstairs in an hour or so. I'm gonna have to make her dinner. I don't know if you successfully found a bug. I think clicking on it too early made it kind of like, Now that you're I'm not an educator. I'm a content creator in their content creator program. They actually have me properly pinned. You make dinner for your dog. How elaborate do you go? What, do you not make dinner for your dog? When we first got Willow, she was open fed, which is where you just make sure that there's kibble in the bowl and she eats it. But the people that I live with were unable to process that type of information. I don't know why. I guess you get to an age and you just can't learn new things about how dogs work, because she was totally happy to be that kind of dog. My friend has a dog that he does that with, and the dog is the most temperamental, like non-temperamental. It has the best demeanor. It's a nice dog. She's a very happy dog. But anyway, the people that we live with decided to get fancy. And so what we do is we take a little bit of wet food, and I shred a little bit of chicken that we cook. We get these little chicken breasts that we cook in the toaster oven, and then I shred that, throw it on top of the wet food, heat it up in the microwave just so it's easy to spread around because it's been in the fridge. Everything gets kind of congealy. And then I dump that on top of the dry food and I smash it with a spoon until it's kind of even, and then I give it to the dog, and that's the dog food. I've tried to keep it simple. They've tried to add fancy stuff to it, like adding a little bit of water to make it, you know, to make sense. Let's put fish oil in there. I do give her fish oil every now and then. It makes her coat super smooth, like super smooth. But, you know, I try to keep it simple, and I've tried to fight to keep it simple. Our dog has a bit of a weight problem. She's not fat. She's maintained at 40 pounds, but corgis are not supposed to be 40 pounds. All right, we've given up on this. This is done. Close the program. Well, let's find out. What do you guys want to know how Fusion 360 handles a crash? I'm going to wait for the computer to kind of climatize. All right, so let's do fuss, but not roda. Fuss yon. Bonk. Let's go. Here we go. Oh, it actually remembered my window size. That's rare. It used to not do that, and it was extremely frustrating. It didn't remember what monitor and what window size, which is like programming 101. That's literally programming 101. That's what they teach you in a 101 C++ course, is how to keep the window coming back up at the same size. There is a problem where, like, if you unplug a monitor and plug it back in, Fusion can get buried in that fray. Here we go. Here's all the recovery documents. Open all of them. We're going to let it think. This computer is starting to get a little bit old. I upgraded this in 2018, I think, to be a mid-level spec machine. It's got a 1080 FTW, which is possibly the best card ever made. Well, the 1080 in general is probably the best card ever made. And it's still a relevant card to this day because consoles hold game technology back significantly. I don't know. I've got my old gaming PC sitting back in the unfinished part of the basement. I could maybe upgrade this thing to that. All right, so our parts dialogue stuff was not up as a recovery document. And we didn't really change anything with these guys. So it doesn't really matter if we have the recovery ones. How much RAM? I have no idea. The properties. No. Let's not show everybody that. Specifications, Windows 10, blah, 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 blah. Man, I got no idea. Yeah, we're 3.9 gigahertz, and I've got 16 gigabytes of RAM. But in doing AutoCAD and streaming, the system is doing its best. It's not slow by any means. I haven't noticed any slowness. But we're using 190% of the CPU. I'll put this aside and just see where it gets in a couple minutes. It's been fine. The only thing that really happens is that Chrome will park tabs sometimes, and that'll lose me my chats. So during a stream, maybe I'll click on these in order to refresh them so that we don't lose. Chrome doesn't park the RAM for those windows. Okay, so we need to get back into the library manager because we're not done. And I guess that's a little bit of what we were doing here. Well, it looks like the pad's saved. So we hadn't done anything with this. So what we're going to do is try to move the parts of this thing so that they represent what's actually there. I don't have to do this for any other reason other than just visual purposes. Although it looks like, oh, there we go, yeah. So we're going to get rid of the 3 in the middle here. and we'll see if that has repercussions. Okay, so now it looks like we can't really do that. Yeah. Okay. So I thought we could just go in here and kind of mess with the model a little bit. I would have just deleted these and then moved them over like they were separate bodies. I can hide them, but I don't know if I can move the other ones. Are they grouped? What do we got here? Remove appearance override, properties, save as mesh, copy, blah, 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 detail control, opacity control, isolate, find in window. I don't know if there's any ungroup those boys. Yeah, I don't know. I can unview this one. We'll get a little closer to the right appearance if I do this. Let me just see, hold on. I'll see if I can move this one independently. It looks like, okay, so it looks like we'll get around this by just unviewing them. And then move them 0.25. Just move them the same for everyone. Okay, looks like we got around that one. We barely made it, but I can't believe you can't delete it. I guess it's just because of the way it was created. You know, this is a fairly unique chip. This is not sort of the typical experience with AutoCAD, but it has allowed me to do the stuff that I want to do. It did say move group. So maybe if I ungroup it, but I didn't find any ungroup controls. See, this says move, oh, move to group. Maybe that's different. Which one is this? Which is it highlighting? 11. Move copy. 0.25. Here we go. All right. We have represented our weird-ass chip on the actual substrate. Using the auto tools and using a little bit of our own ingenuity, we were able to modify this in order to match up with its own footprint. So now we have a 3D model, a full 3D model of this thing. So I can go over to manage. Oh no, maybe not. Maybe I could just save it like it is. Save, click OK. Now, because I have not associated anything with that component yet, this is going to save, and it's just going to be part of that list of components. It'll just be an unassigned package. And I've got a bit of a problem with unassigned packages in my library, if you know what I mean, because I don't. No, what I mean is that I've deleted a bunch of extra stuff that I'm not using. And so those other two lists of things, the footprints and the diagrams, were not also cleaned out when I cleaned out the main thing. So I need to kind of go back through, and I think the best way to do it is to start a new library, and then I can pull stuff over to that library, and then it won't take all of the detritus with it. But that's going to be a lot of work, and I'll need my concentration drugs in order to even approach that one. Okay, so that's all done. I hit save. Everybody's happy. We don't have like a utility to close here. I'm just going to close that straight up. All of our recovered documents, even though we didn't change anything, are still here. We need to reopen the library manager because it didn't, because Fusion is kind of like staple. They put a bunch of tape on Fusion, like a bunch of double-sided tape, and then they pressed it up against, sorry, they took Eagle and they put a bunch of double-sided tape on it and they kind of pressed it up against Fusion. and their AutoCAD stuff. And so it's kind of like not really built in fully. It's been getting better. They've been doing a lot of work in that sense to kind of build it in and make it work like the rest of AutoCAD. But what happened was we were in the library manager editing stuff, and then the computer crashed, or the program crashed, and so it didn't reopen the library manager, which is annoying, but it's just a result of them kind of pasting a library manager into the rest of the design. So we're not looking at all libraries. I need to look at chips managed. And so in chips managed, I have the something, 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 something. What was it called again? It was with the TL074s, because it started with a T, right? TLP, no, TPA 6120. Open that up. Oh no, that's placing it. Hold on, no, we don't want to place it. Right click, edit. Edit to Z library. So here's our component. We have no 3D model, we have no footprint. New, add a local package. So now we are associating that package that we just finished creating, two files that are in the, you know, sort of treed against one another. We add the local package, and now we look for it in here, and it's QF something, something, something. No, 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 yes. So here's our part. We're going to put it in as a variant, and the variant's just going to be QFN. So the variant is just what you're using to describe the different packages that are associated with that chip. This one only comes, well, actually, this one does have a like an SOIC, and I've literally got one sitting right in front of me. I bought an evaluation board, and there's literally, this is the other package that it comes in. There is no way in hell that this thing is fitting onto a 2U setup. It is just as wide as the stereo right angle board plug, but yeah, this is what I can use in order to derive what some of the capacitor values, the appropriate capacitor values would be in this system. We could do a modicum of reverse engineering. One thing that concerns me though, they have their power coming in here, right? Yeah, and we make our 2 voltages here. Oh, those are some big capacitors. Those are some, wait a minute. Hey, how many caps do I need? Oh my God. What is going on? Why are there so many capacitors? I don't know. I don't know if we need that many capacitors. If we need that many capacitors? It's starting to concern me a little bit. Anyway, okay, so if we click OK, now we've got our QFN in here. It's got the pad numbers. It has sort of the 3D model that it's going to be placing on top of those pads. But what it doesn't know is what schematic components here connect to which pads. So now we need to associate the two with one another. Yeah. Hey, when the power turns off, how long does your headphone amplifier stay on? Well, until power comes back. How long is that? A year? Ridiculous. So we hit connect. Oh yeah, and our prefix, by the way. Don't forget the prefix. Our prefix is just U. So inductors L, chips are U, resistors are R. You know, you've got to define it in there. So we hit connect, and now, because we've called them R and L, we have PL and U1L and U1R. So we're actually able to associate these with the proper pins because we have a left and a right, because we renamed those things. So that helps us immensely in order to keep this from getting out of hand. So now I'm going to open up the data chart, and we're going to take a look and associate all the right things with all the right things. So this will be on my other monitor. This is multi-monitors and creating PCBs. I would have 5 monitors, and I would still utilize all of them. If I had 2 monitors sitting above these two, actually it would be nice to have the video layout like up top. I'm not going to get too many monitors on this machine. If I were doing this like professionally, if I was hired to do PCBs for somebody, I would want more monitors, and there would never be a condition under which I would have enough. It just wouldn't exist. Okay, so power left V plus. So that's LVCC plus, that's pin 14. Power left V minus. So LVCC minus is pin 12. Power right V plus, RVCC, pin 8. Power right V minus, RVCC minus, pin 10. U1 left plus in. So that's L in plus pin 1. U1 left minus in pin 2. U1 left output pin 13. I memorized these. That's why I'm so good at this. U1 right plus in 7. Sorry, I had to remember there for a little bit. U1 right minus in pin 6. That's all up here. U1 right output pin 9. And then what did it say that it wanted the ground pad to be connected to? Did they say, I don't know if they said ground. They said they wanted it to be connected. I think they did say they wanted it to be connected to ground. So I think we need to actually add a pin. Connects to ground. The thermal pad must be soldered down in all applications. So we need a pin that's going to be specified as ground. Just one pin. So I guess I'm just going to throw that in here. Let's do, well, actually, can I add, do we have a ground? Power G, yeah, okay, so power G, this is just a ground pin. So we're just gonna pop that in there and click done. And now if I go to the connect dialog, I now have, oh yeah, we need to U1 properties on that one. We need to call it U1G. And then I'm gonna hit connect. Now I have our U1 ground, pin 15. Connect. Bada bing. 3, 4, 5, and 11. Let's double check 3, 4, 5, and 11. So during the course of working on this thing, this is what's been going on. Memory is at 65-ish%. CPU is at 50 to 100. The computer is working. It's water cooled too, so there's no way. My eurorack PSU would sure love all these capacitors when I turn the case on. Seriously. I don't have that many capacitors in my power supply design. I just have really nice power supplies. For the eurorack stuff, I don't buy somebody else's power supply. I put together my own power thing that sits at the bottom there, and it uses Pololu voltage regulators, which are like robotics grade regulators. They can be pushed to their absolute limit and not even break a sweat. But for eurorack, you don't need too much current. I just wanted the stability of having an extremely modern power brick in the thing. So my plus and minus 12 volts are like rock solid. Yeah, 3, 4, 5, and 11. Where are those pins? What are those pins? Hold on, I'm getting the data sheet. Where's that? So pins 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. They're all NCs. We don't have to worry about sucker NCs. And we're done. We have a new part. Let's hit save before something horrible happens. Control S. Now, saving is not the end of it because we use a managed library. And a managed library is uploaded to library.io in the cloud. The cloud people are going to benefit greatly from my work. However, we still need to upload it to the cloud. That way, all of my machines have my library. So if and one of the things that I would like to do, I bought a Legion Go, and I haven't had a huge amount of time to mess with it. What I'd love to do is do a stream where we put AutoCAD on the Legion Go and see how it runs this program. If I can do CAD on the go. So we upload it, it's gonna write over the one that's already there and then re-download it. Good work. We're doing good work. We're doing good work. We had a big crash, lost a lot of, well, we didn't really lose anything in the crash, but we had a big crash, got it back. We're doing good. All right, so now we can actually put this into the design and we can see our design come to fruition. What's with all the pads on this? It shouldn't have the excess pads. I don't know why there's so many circles weird. I guess it's just a factor of how it's viewed. So we can go all the way back to the schematic, and I can drop in our audio amplifier component. Place component. Chips managed is our library. Scroll down to the bottom. We have our TPA6120A2. Double click on that, and it'll look like a little amplifier, and we drop that, and we drop that, and then we've got power, and then power for the other side, and then we have our ground pin that I'll just put kind of down here in the frame. And now it wants me to add another one, but I won't. U3 U1L. Okay, so we're gonna go back to that. Let's go back to this and edit the component again. Properties. We'll just make it R and L. R and L, and then this one is just going to be called G. Because I guess the other part of the program will end up assigning it with the U. So now I'm going to save that. Click OK. Then we're going to upchuck it. And that'll fix that little naming issue. Beep, boop, beep. Computer go. Then it downloads it, overwrites my library, blah, blah, blah. There we go. Okay. So back into here, and I guess what I'll do, I'm just to be nice, I'm going to delete it completely, just eradicate the whole part. And we'll see if that puts in the proper part now. You can, because the way Fusion works, the library and the components that you use are associated with the file. And so if you've got old components in the file, the program will sometimes catch that and allow you to update it, but sometimes you confuse it, or maybe something doesn't quite update right. So your components that are within this design, and which that's very convenient, because if you share the actual like SCH file that Fusion outputs, somebody else can open it up in Fusion. All the parts are there properly. They can import your parts into their library so that they can use it in the future. I mean, that's a great attitude for parts, although I don't know if everybody shares it. I don't know if companies would share that attitude, but I like the fact that if I open something up and somebody's created a custom part, I can grab that part and then incorporate it into designs. So it's all associated with the files. If you really want to, if you want to obfuscate it and keep your design secret, I'll put a PDF. Oh, here we go. Check for updates. There we go. Okay, so we checked for updates using the little dialog menu, and now I think it should all be sorted out. Yep, U3R. There we go. R and L, power R, power L, and then ground. I guess I could pull this up into this, and we'll do. So let's get the library manager out of here, and I'm just going to wire it up real quick. So I'll do a copy of the ground. Dang it. Over there, and then I need a plus and a minus for the power. We're going to need two of them. So V plus there. V plus here, V negative, yaw, and then yaw. I'm going to need a resistor, two resistors actually, so let's take the whole thing and move it forward just a little bit. So we got room for that. Jim Jam. Doink. And copy this, floppy this. Dang it. Yeah, the design may need to bleed over into a couple pages. That, or I think I can tighten up the bolts on everything. You know, get the. Why would you do that? why would you do that? You've got to squeeze every pixel out of the design in order to get it to fit. I think I'll be able to fit it though. Probably could use a more compact resistor symbol. I never got around to doing that. Why? And then this can move in just a little bit. Well, no, because I need to have something coming up off of it. And then we'll duplicate this resistor, put that up here. Oh yeah, and then I'm going to need another op amp on it. Oh no, wait, this is a little different, isn't it? Yeah, hold on. We'll have to reconcile this later. I'll just put the components down for now. Because then this has another resistor that goes to ground. And then this has the feedback resistor. Remember, only use three-way junctions. There, and then we've got another resistor on the output. That's like 39.2K or something. It's a weird system. And actually what I can do is I can take all this, I can move that up. Well, I'm going to need a little bit of room underneath on the other one. So maybe I'll move it like to there, and then I can move this in under it because it's getting, well, no, this is actually, I think this is the limit. Because one of them's coming from up here. One of them's coming from this junction here, and then the other one's coming from this junction here. It's basically across this amplifier. But that's what the circuit's going to look like, and then this goes into the headphone jack on R or L, depending on which tip, ring, and sleeve is. I'll have to equate that to the layout. I haven't figured out all the specifics of that yet, but let's just make that circuit over here again. There. Oops. I'm not worried about what R numbers and what, L numbers or whatever are on this thing, because I will do something at the end that will rename all the R's and the L's depending on how the schematic is laid out. There's a little dialogue that you can do that'll just sort of steamroll over all of your R's and L's and C's. But I don't worry about that until the end. Actually, move this back one. Just a little bit more compact. So here to there, here to there. This down. Nope. No. Dang it. Okay. There, up to there. There we go. And then you go to you. This goes to here. This goes to here. This goes to here. Attached. Oh. Yes. Okay. And then you two. That. And then we grab a ground. Copying this. So it's not as intuitive. Well, I mean, I guess it is pretty intuitive. This is how most CAD programs, I guess, do their thing. It's just knowing what to click and, when to click what. And I'm trying to tell you guys what I'm doing while I'm doing it. I am working at like lightning speed right now. Most CAD programs have a pretty clunky way of doing cut and paste maneuvers and, selecting certain things without getting other things in the selection. And then on top of that, there's a whole diatribe about circuit layout and how I like to organize things. My whole thing about no four-way junctions. Now, which plugs into plus and which plugs into minus? That's what I don't know. Also, that's also a no-no. I don't like to come directly off of these pins. I like to give them one spacing of breathing room. That's something I'm going to have to reconcile like immediately. Which one goes to where? Which one goes to the inverted and which one doesn't? Let's find out. So these are reversed, but they still have, it's a symmetrical layout. So if I'm looking at what's connected here, the side with one no connect is this side. Our outputs are coming out of here. This is, let's see, this is our inverted input, the one all the way at the end of the schematic. And that goes to this wire that goes over here. Where it goes into this one that has the feedback. So the one at the very end goes to the one that goes with the feedback. Oh, but I did this wrong. This is wrong. Hold on. Let's double check on the schematic over here. Their example. Yeah, they're reversing plus and minus. That's very confusing. When you start working with op amps, you need to make sure to verify the plus and the minus, because they'll flip them willy-nilly, whatever makes their circuit work out in the end. I wish you were CirCAD. CirCAD would let me just grab only the component and flip it around. There may be a way to do that in AutoCAD that I just don't know about. So to flip this, I click and hold, right click, and then center click. Center click just mirrors it. And so now I can drop it back in where it was and do the same thing with the other one. Of course, I disconnect all this stuff first so it doesn't make a mess. Grab just the component, right click, center click, and then move this back into position. The text is in the way. We can move that later. Boom to boom, boom to boom, boom to boom. And so now the inverted one all the way on the end goes to our negative. Appropriately. Okay, so, oh yeah, hold on, let's finish this. Finish what you started. This down to here, this to that space right there. I can probably kind of clean this up and get it all to fit, but then the question is, what is tip, ring, and shield? Well, in which order do we want things to be in? We want right, left, top, down, right, left. So that would mean that this is right on top, this is left on the bottom. So tip, ring, shield, pin out. Left, tip. P1, P2, P3. I am going to have to assume, because this isn't quite the way that it is, but usually the Thonky Kongs are tips. So if the tip is, what was the tip again? Only for a minute. So left is the tip. That's awkward. It is always awkward when I start talking about tips. All right, what? Why did that go down? Get out of here. So what I can do is just flip it like that, and then now we're in the right order. I'll just put it out here. We'll get it to fit later. And then we need to pull in a ground. I'll just put it there, and then we can just do this. Bada bing. Now, supposedly that'll work out. It's the symbol of a mono connector. I didn't feel like making the symbol of a stereo connector. It's just the symbol of a mono connector. Both plugs are 3 pins. The stereo Thonky Kong does not have the switch disconnects in it. So I just stole the symbol. Who cares? So this is just something that I happen to know. Okay, that is connected. Okay, so now that we've got our full schematic, we can jump over to the 2D design, and we can take a look at our new chip, and we can try to locate it on this board. So let's do this. That's gonna chooch away. And we've got all of these air wires. The air wires we can unview if we really need to, but these are just defining what pins need to be connected where. And since we've done all of the schematic work, it is a bit of a mess. But let's just get our major players down and see what happens. So if I center click and hold, center click, it drops it down to the bottom layer. This is going to be a 4-layer design. And pretty much the last piece of this is going to be what this chip does. So I'll place this here, and I guess it is in left and right configuration. That's left and right, so it may want to go over here, but I don't know if I have room. We've got another set of op amps here. These are going to be tricky. These will really only fit under the knobs. But the routing, I need them both to be in kind of the same spot. This is where things get really difficult to figure out. Because if we're too close to this, we're not going to have room for the traces. Like, I can get this a little closer. But I really want that room around it. And then this, I mean, like, if I install the Donkey Kong and then I totally flatten down the leads, I could make that maybe work. It's still kind of a big struggle to get in there. This is, of course, an ideal area because we've got all this room surrounding. We can make this work. We can make this work. It's going to be very difficult to make it work, but we're going to make it work. I don't know precisely how I'm going to go about this. This has been worrying me for some time. I don't know. Well, I've got one. I've got one around here somewhere. Let me find it. I have a stereo Donkey Kong. What happened to that? Where did I end up putting it? There are thonks in here, but I don't know if the stereo... What happened to the stereo one? I think it was still in its packaging. Oh, and I still have to actually plug these things into a pair of headphones. Dear God. That's a screen. That should go with the screens. Oh, these are the screens. Oh, where did you go, stereo Donkey Kong? Worry is content. I'm doing it! I'm making content! Yeah, no, I've been concerned about fitting all this stuff in, because it sure is not a lot of space. We have a lot of no space. Where did you go, oh stereo Donkey Kong that I ordered one of? Hold on, here. Yeah, it's green. It's bright green, and it's somewhere around here. And I don't think it got to the same spot as all the other ones. I think it was still in its packaging. And I think I like, most stuff kind of has this ebb and flow in this shop. So things end up kind of flowing behind other things. This is that cool pattern maker the wall projection thing. The punch set can go over here. Doesn't look like there's a lot over here. Ain't there. Where have you gone, stereo thonk? The one that I have, it should be in the bin with the other thonks, but I'm looking at the thonk bin and I'm not seeing it. This is where the thonks are. Some of the thonks are. Yeah, I don't see it in here. Wait. There it is. Is it really a millimeter wider? I sincerely hope not, because that's going to be a lot of engineering work that I now need to do on the back end in order to vet out whether or not this thing fits. What's up, Einstein? It's him! It's Einstein! He's in the chat! Oh my God! Drop Einstein in the chat. I'm gonna put a bunch of these Donkey Kongs in here. It's the guy. It's him. Relativity guy. Do an equation. Do an equation. Yeah, reloading. This is going to be trouble. Nah, it's the same. You're going to make me question these things. The body is, I think, a little bit taller. Like, there's like 1/10 of a millimeter or something. Oh, it is a millimeter wider, though. Oh, that's a beast. Well, well, well. How am I going to deal with that? Well, I think it's still going to fit in the in this design. It'll just be a little bit bigger, because this is the stereo thonk down here. It's going to have to fit inside it. We'll see overall dimensions on this thing. Is it going to fit within 10 millimeter? It is 10 millimeters. So yeah, it's just going to be the same thing. As long as the pin spacing is the same, we're totally fine. And it is. Yeah, it's just a little bit wider. But with this, that's fine. It'll still fit within the setup here. If we had to add another Eurorack space, I would have had quite a bit of issue. What the heck was that? Willow Fan donated $5. Hey, I actually caught that. I almost lost that. Willow Fan, thank you for the $5. That's very nice of you. $7. I'm sorry, I can't even. For Xmas Doggo treats. We do have special Christmas treats, and my mother bought us like 4 packs of them because she dodders over this dog, and I try to keep the dog thin, but then we end up getting sent home with a bunch. And then Veet Nukem was the last monetary donation that we've had for using a particular type of wire, and I do have some of it, so we'll use a little bit of that wire and see what it's like. But man, okay, thank you for the cash, Willow Fan. She's upstairs sleeping. I don't know if I can get her to come down here. Willow, are you gonna come visit? Come here, puppy. Willow. Nah, I don't think she's gonna come down. She doesn't like all the hassle and the noise. She likes to go upstairs, take a nice nap, and that's her sort of afternoon. She got to play with the neighbors' dogs today too. I took her out and we ran all over the place. She was running. She had to poop. Like, it's crazy. When she has to go, she will pull you. So my only option is either to put this chip under the potentiometer where it will actually fit and nothing will intrude on its space. But I've got 2 potentiometers in here. One is at the top of the circuit, one's at the bottom. We have a lot of op amps that need to do their jobs with this stuff before it goes to these chips. Having these chips on such opposite ends of the circuit, I guess it's just what we have to do. I guess it's just what I have to do. So if I put them like that, but then this one goes to the very last stage, right? That may be a ground wire. Well, just for the purposes of saying whether or not this is possible, there's a lot of background work that I'm going to have to do in order to get these things arranged properly about whether or not U1 or U2 is it. So let's hold on. Quick look at the schematic. Oh, look, the chip that I was holding on to actually highlights. That's kind of cool. So if I click on something in the PCB layout, and I'm like this here, and I go back to the schematic, it highlights that chip. That's cool. I wonder if you could take advantage of that with multi-monitor setups and have, it would be really cool looking because it would be like highlighting parts of your schematic while you're working with it. First stage op amp, that is going to be U or IC2. Why is that coming in as IC? Oh man. IC2. I'm gonna have to go into the part and edit that. So this would be the first stage. We'll put that with the That's probably going to be U1 for the other one, right? This is getting in the way. Can you move maybe? Nope. U1, okay. See, that's the problem, is like they're not all named U. We go into U1, which is over here. Go. So yeah, U1 is kind of an unfortunate place, but I have to use the underside of the potentiometers for these chips. They won't fit anywhere else without a pin protruding through them. And then the spacing is a little weird. So this is where you kind of massage all of your components in order to get them to be in sort of the best layout for your traces to exist. Now, we have some troubles with that because our stuff is all over the place, and our space restrictions are palpable. It is going to be fairly difficult for me to lay all this stuff out properly. There's going to be a lot of weird things that I have to do in order to make this work. But as an initial test of just whether or not components will go down and fit without putting all these resistors in, we can render this PCB in 3 dimensions and we can see all of our parts. So let's click on this here. I'm going to check to see. Yeah, okay, not a lot of activity. Did I get Chester Willard for 50 months and then Wonky Robot for 10 months? 10 months of streams that start too soon. Oh no, that starts soon. Merry holidays. Merry holidays to you as well. Oh yeah, I have to push. Push. I'm gonna push that out onto the floor. Man, Orlin the Mage. There's just this huge block of gift subs, and then right below it, it says 11 days ago, Code Rush rated with a party of 10. Man, Orlin the Mage, thank you so much for being very generous. I appreciate the whales. Is this a custom part, or did I just recolor? No, you know what? I don't think I retouched it. Kind of does look like I did, though. It is wider. Okay, so the actual 3D model is wider. I need to make the pads and stuff that actually agree with that. I made it out of kind of a normal Funky Kong part. Here, all the resistors and stuff that I have to somehow sprinkle on this thing like I'm Salt Bae. Oh boy. I mean, shit. There's barely even room for these components to exist in the first place. And we forgot something. We forgot something. We forgot power. Power is going to be coming in on a normal header. So we're going to have to place a normal header somewhere in here. So this would be connectors generic. And we're going to go with an MO5. MO5. I made sure that I had 3D MO5s. Oh, because it's the placeholder. Yeah, the placeholder is kind of annoying. So I didn't actually do square headers for this. I'm going to need to do square headers for this. So we're actually going to edit this component. I need square headers in order to represent the actual square headers that I'm going to be putting on this thing. So because I've got long and thin pads, and then I got rid of all that SparkFun waffle with their weirdo pin, like their staggered pins, so that it holds onto your component a little better. Yeah, it's pointless. I don't need that kind of helper. So we're gonna do a model of a square pin. I think I have a model of a square pin. Let me check in my stuff. So this would be not here. We're going to my admin projects. That's where I keep all the library fodder. The thing about the 3-dimensional parts is that it creates a lot of files. You're going to have a lot of files, a lot of 3D files and a lot of 2D files. What are you doing for Christmas? Merry Christmas. We're going to have a couple people over. My folks are coming over, and my uncle and a family friend. We're just having a little get-together because my folks are actually in Maryland right now with my brother and all his kids. They really wanted Willow to go down with them, but I think my folks wouldn't have been able to really handle the extra craziness of having the corgi. But I'm sure Willow would have really liked to see her family down in Maryland. She's here with me. It's just us for a couple days. And then once they get back, we'll have a bunch of people over for Christmas Day. And as usual, I tell them, like, I don't want anything. Don't get me anything. I got plenty of stuff that I need to worry about right now. I'm just in it for the holiday, hanging out with family. So let's take a look here. We've got 3D pads. Those are parts with pads, 3D part models. 3D parts that have no library associated with them. And then the rest of the stuff is just crap. So let's look up part no library and see what we got. These are electrical parts that don't really have a footprint associated with them. This one is in the wrong folder. So here we have the headers that I started out with, the circular pin ones, but I don't have a square header. Let's check in the models only. We don't really have a singular, it would be a singular square pin, and then you'd do a pattern of those. So let's find a square pin. Actually, there are, AutoCAD like can generate their own, right? They can generate a square pin. I don't really want to do that because I don't like their square pins. I don't think they generate properly. So what we're going to do is we're going to go to GrabCAD. GrabCAD is an additive manufacturer, additive manufacturer. They're a manufacturing company that bought a database that was filled with 3D models. So we go to GrabCAD. Well, normally you wouldn't land on the library section. That was my browser filling that in. You would go to GrabCAD and it looks like something else. You're like, well, this isn't really a website that I'd need to go to. It's not, you know, I'm not looking for a manufacturer. This is like a professional web page. Well, what they did is they bought this database of three-dimensional designs, a lot of it being done in like AutoCAD and similar programs, and they kind of hit it. Back here they have library, and you click on the library, boom, there's the whole database. So they're not exactly steamrolling a community effort to get models out there. They are kind of hiding it behind their front door as sort of the price of entry. So GrabCAD gets that promotion, and we get to keep our giant library of stuff. They'll continue to host it. So anyway, what we're looking for is square header. Why is there so few? Pin header. I'm just looking for the most common kind of pin header, not something that looks, you know, underrepresented and not something that looks super overrepresented. I would like to have that cut in the side. This is pretty close. Pretty close. Oh, where did it go? There it is. What I'm really looking for is one pin, but I don't think they're gonna, yeah, I think that's the limit of it. Okay, so let's just use that one. So I need to sign in. Let me just do that real quick. All right, download the files. So now I've got this thing in the downloads. Back over here. Parametric fusion, blah, blah, blah. Extract it. And now we can go to my, which folder? I guess 3D part models is a pretty good one to upload it to. Go to the upload dialog. Open up the folder. Why are there two? Why are there two? There's this one and there's this one. They're both F3D. Header 2 and header. No explanation as to what the difference is. Let's take a look at the listing again. There are two versions. The only difference is the looks. Huh? What's the... Wait, what? What about the looks? One's a little bit more gold than the other? Seems the bodies cannot combine automatically after the pattern, so you need to do it manually if you need to, but using it as a component works for me. Yeah, that's all I really needed. When using the parameters, you can modify the pin numbers and row numbers as you please. Oh, that's neat. So, mahalo! Mahalo! Hey, everybody's coming out of the woodwork and subbing. Merry Solstice. Merry Solstice to you, too. Thank you for the 64 months. Appreciate that, Mahalo. Yeah, there was somebody came out of the woodwork that I haven't seen in ages and ages, and they left a comment at the beginning of the stream. Crazy. What is that? Wait. Oh, it's a little snowman waving high. That's not a bad emote. If that's limited time emote, it actually looks okay for a Twitch emote. Usually Twitch emotes are like way too designed and busy. That one's nice and simple. You can see that it's a snowman. Although on a dark background, it makes it a little harder to see the waving, the stick arm. Okay, so which one do I want? I guess I'll just take one of them. Let's just do like the second one. It looks a little bit more gold. Not that I'm sitting here doing renders. Parametric pin header. I think they introduce slowness to these uploads. It's been getting better and better, but sometimes they like hang up for an extremely long amount of time. So parametric pin header 2. Let's open that up as its own thing. And we can look at the parameters and modify them. Where was that? It was modify parameters. Change parameters. Change places. Number of rows 1, number of pins 2. Make it 5. Not A5, make it 5. Bada bing. So I'm going to save this as 5-pin header. Should really be 5x1, but I'll just call it 5-pin header. Okay, so now I need to go back into the part that we were modifying. And I guess what I can do is take right. Okay, so what I do is I go back to the tree, and in MO5, I go to 1x05, right click, and do create new 3D model. I think instead of attach existing, create new, and then that gives me this window with the pads. So I'm going to save that as 1x05. Yeah, just the regular 1x05. And so now we're in the 3D editing, but we can see that we've got this sort of guideline about where the pads are. So I can take the design that we just made, somewhere in here. That's probably all the way up top, yeah. 5-pin header, drop it, pop it, lock it, move it into position, 90 degrees, this way 90. And then what I'll do is I'll use a point-to-point move in order to move the whole thing into position. So I'll do a point here, and that'll be the center of the pin. And the next point is the center of the hole. And I go to this move, and now I bring it down until it's just over the surface. I'll give that a little tiny bit of a gap. It's not going to be totally vital that I get it to be perfectly aligned. And when you solder it in, it should butt right up against that. But if you're doing like a header and standoff kind of ordeal, it may not, well, that might actually factor into it a little bit. If I'm going to have 3D printed, like let's say for instance in the future, if I do something with 5 pins and it's sticking up just a little bit, I'll have to go back in and edit this in order to tighten it up. But for right now, for our purposes, this is totally fine. So I'm just going to leave it like this. I know that I tend to do things this way. And so as long as I know that, maybe in the future when I'm super confused about why I'm screwing myself over on dimensions, I can remember this little tidbit. Oh yeah, I put it above just on the basis of feeling. Okay, so that variant, well, that should have made our variant in here. Oh, maybe we just, well, we attached the model. Wait a minute, cancel. Does that just mean the model's just floating free? That's weird because we attached a package. This little symbol means that it's a placeholder. I guess I need to go back in and do new local package and then find 1x5 with the 3D model. And really it should be called PTH, but I guess just TH through hole. Connect. Well, that's easy enough. Okay. Prefix is J. This one is TH. PTH, you can be deleted. There we go. So there's our 1x05 through hole that we're now going to add to our design. So I'm going to push, hit save, click OK, and push this out. There's a lot of component creation in this kind of thing, especially with my insistence on having an extremely detailed three-dimensional model of the entire circuit. That ends up creating a lot of working tasks involving importing weird parts, or even sometimes just normal parts that I just don't have. I simply don't have 3D models of. We're getting there. We're getting there. There's going to be a lot of background work, and that's what I'll be working on until, you know, well, what the holiday is on Thursday, isn't it? Or it's Wednesday. Yeah, the holiday is on Wednesday. So yeah, we've got, maybe I'll do a Christmas Eve stream. We'll see. Christmas Day, I'll have to figure out whether or not I'm doing a stream on. I don't know. I might not. And I'll certainly be back on the Friday of next week. The Tuesday of this week, let's see. Yeah, that's the Christmas Eve, Christmas Day, post Boxing Day, and then the Friday I'll definitely be on. But we'll see what the holiday schedule ends up working out like. Okay, so we've got our through-hole part in the library now. I'm going to close off the library manager. We don't need the 5-pin header open anymore. We are going to go back to the schematic, which this window shouldn't be there. It should be. Anyway, we go back to the schematic, and now I'm going to add in my power thing. So I'm going to place components, connectors generic, and we're going to do M05. And then the variant, oh, we need to update it. Check for updates. Check for updates is a little right click. M05. Why is it still showing me a placeholder? Now, what the hell? TH is the variant that I just made, and it has a three-dimensional design associated with it. And I saved it and closed it, and everything was associated, and everything was there. Just in here, there's no preview. All right, well, let's trust the system, and let's put down our power plug, our 5-pin power plug, and let's just see if that comes out in the final design. So we go over here, and it's added our component way down here. These air wires are very, very distracting. They're kind of crazy. I'm going to have to kind of rein things in and make that work. Now, how are we going to do power on this thing? Pretty much anywhere that I have a little bit of space, I can sort of sneak in where the power plug's going to go. Although, yeah, this is very tough to do. Like maybe I can put it here. Oh, and I need to flip it over to the other side. So center click, and it flips over to the other side of the board. So if I can sneak it in there and hopefully not destroy everything, let's take a look at it in 3 dimensions. Push. Takes a bit. It's got to do a lot of stuff. All right. All right. All right. Whoa, whoa. Oh, I forgot. Merry Christmas to you too, Journey started. Thank you. 3, 2, 1. Oh, did it do it? It did it. So with a generic header in place, we can see what kind of a restriction this is. This is a This is one of the smaller components that you would encounter while messing around with electronics is a standard 0.1 inch spaced pin header. It's causing chaos, utter chaos. The neat thing about the Donkey Kongs, though, is that they're mostly hollow. So it might actually fit without having... Oh, God. Okay. There may be a way that I could arrange it so that the negative space of the Donkey Kong is actually where that pin header ends up falling. Whoa, why are we 1,000 miles away? What's up, Long Dog? How you doing? But the thing is, like, I'm probably going to have to do it like this, and I'll probably have to shave the ends of the pins off so that the solder pad is flat so that the Donkey Kong connector can still fit properly. I don't want to do something like modify the Donkey Kong connector. I think it's better just keep everything kind of the same. But you can always take flush cutters to the ends of these and try to flatten them out with files. Using a file is kind of not great because if you misalign the file a little bit, you'll end up hitting your solder mask. So. A deep crash, geez. I was able to talk and be feisty and combative. Yeah, that's always, yep. Anything's wrong. Yep, that's a common mental thing that happens with hypoglycemia. When you go hypoglycemic and people are surrounding you, telling you that you're acting weird, you're hypoglycemic, you always push back against it. It's just something that happens. EMTs deal with it a lot, and it's sort of like, I was dreaming, and now I need to get out of this weird dream that I was in, and you're insisting on having me drink something, and I don't want that because I don't know what's going on. I don't know what's in that. It's a common response. It's a very common response. Total confusion didn't make sense. I even partially told myself something's wrong when I could not work the microwave and change the power settings. Oh yeah, I had hanging out with coworkers just around my desk. Everybody was standing around my desk. Unbeknownst to me, my glucose level spiked down. And so I said something that was kind of like a quippy little joke to me. It didn't make any sense. And everybody in the circle kind of went, like, did a nervous laugh. They were kind of, huh? And I'm like, why did they react that way? I said something completely logical, something about a banana. And I was like, whoa, wait a minute. If they're reacting like that. And so I did a glucose level and it was like super low. But apparently that's a thing that happens. Like your brain loses fuel. And so your brain is like, what am I supposed to do here? What? Well, what happened to the circuit? It went all weird. I've had it powered up this entire time, just kind of having it idle. This is the weirdness of what the solderless breadboard does to a project. As you can see, these waves are super duper crazy, and we've been just kind of letting this sit here for a while. Maybe I just turned it up a little too far. Look at how why is that cup like that? It kind of inverts. Oh yeah, see in there we lost some. This is just from the breadboard, because the breadboard, your components, your connections are sometimes kind of bad. Like there, that fixed it. Whoa, what's going on there? This is why I want to move this to the PCB as soon as possible. I knew you'd have an understanding in a similar situation. I'm not trying to one-up your story. I'm trying to say it is a known thing, and it has happened to me. It was weird. It's very weird to be on the receiving end of that. The other time was when I was on vacation in Bermuda, and I was reading a book, and then the next time I sort of started logging memory was waking up from a dream and having my, like, somebody who was having basically a panic attack over me being passed out, shoving stuff with sugar in my face. And I was like, whoa, 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 because I ate some rum cake, and I guess I gave too much insulin for the rum cake, and because there's rum in the rum cake, my liver went, we're good, we're not doing glucagon. And so I crashed and passed out while reading. Not good, but it's sort of coming out of a dream, and everybody around you is doddering over you, and it's like, whoa, 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 what's going on? Everybody stop. I can handle this. I've handled myself for some time. And the mentality is like, it's not like you don't know you're going crazy. Your brain doesn't know it's underfueled, because your brain is what's observing it. Your brain cannot observe itself. You know, your brain doesn't go, huh, brain is weird today, because you go, this is the thought that makes sense to me, and it's your own brain coming up with it. So you can't evaluate it from a a reasonable perspective. It's very strange stuff. It's something that my dad kind of understands as a psychiatrist, but a lot of people just don't. Yeah. Similar situation was in Idaho, and I was wrapping a bandage around my dad's leg, and my mom was with me. What? And then you just like wake up in a weird situation. Yeah, it's very strange stuff. Brains and diabetes, but when the brain doesn't get enough fuel, it does weird stuff. I don't know if we're gonna have to like tilt these, because I think turning them 90 degrees might make it easier for me to get components around them and traces around them. Yeah, next thing you wake up and there's paramedics. Yeah. And they deal with that a lot. They deal with combative diabetics quite a bit just because of that, the way that works. I mean, this is looking pretty doable. Ooh, do I look doable to you? All right, this is looking pretty doable. I think we can actually make this happen. It's going to be kind of a shit show because the inputs are coming from here, 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 and here, routing through one of these, and then the controls are coming from here, here, and here, and routing through another one of these. So I think I'm going to have to split duties. I think maybe, I think one of these will have to go through one of the op amps here, another one going through another op amp here, and then this one will go through there. So the U's and the C's and the whatevers are all going to be split all up all over the place. I never wanted it to happen to, wait, what's up? Next thing, woke up with paramedics. I never wanted that to happen in the presence of my parents. Yeah, that's especially, yeah, that is a thing. They never experienced me do something like that. Scared the heck out of them. That's the thing that I don't like, is that you scare the living crap out of people. I did mushrooms at Burning Man, but I did too many of them, and apparently I don't remember a lot of what happened. And then I woke up in my tent, looked at my glucose meter, everything was fine, felt fine. Looked for my glucose monitor, did a level, it was still fine. This is the early days of CGM. Everything was good. I exit the tent, everyone's mad at me. And I'm like, I don't know what I did. I don't know what I did, but everyone was mad at me. And there was this air of everyone being mad at me. And you've got to kind of walk on eggshells and figure out why everybody's pissed off at you. I didn't do it intentionally. Sorry. I can't reconcile with, you know, the memories I don't have to get a perspective on it. I don't know what I did. Why is this all wonky? This is working a minute ago. Maybe it got mad at me too. Is that how we're gonna do this? You're just gonna be mad at me? Come on, man. Come on back. Come on back. All right, that's a little better. Where's my triangle? Come on, triangle. No sawtooth. See, this thing isn't doing anything. Do we get a little sawtooth? A little sawtooth action? No? Okay. Huh. Just stuff kind of slips up and then it... I really wish I could be more efficient with these SO16s, but it just doesn't look like they sell the... How many channels are we checking with the scope? Looks like you got 4 probes going. I got 4 channels running, but it's 2 channel input and then looking at the 2 channel output because it's left and right stereo. So I would need many, many channels on a scope in order to view everything that's going on. What was I going to look up? Oh, the SSI 2164. This only comes in through hole, or sorry, in SOIC. They don't do package parameters on this. So SSI 2164. See, they also sell one that is a 6-channel mixer, but that's 6 channels into one. So that's not what I'm looking for. This is just the datasheet that we were looking at just now. Sound semiconductor. Hello. 44, 2161, 2164. package specifications. That's it. That's all we get. Damn it. You guys didn't see that. Damn it. Voltage controlled low pass, BCA, voltage controlled amplifier. Oh, but it's in a huge package. Multi-mode filter. Oh, I see. This is just one. That would actually, huh. No, because I would need 2 of these chips and that would take up a huge amount of space. So that doesn't really help me. Using the quads, it's actually more space efficient than having a single. If this were a double, maybe I'd think about getting it. But it's not a double, it's just one. So that doesn't help me at all. Damn. $21.62. Ah, well, this might actually, that might actually save me. It would make this a little bit shorter, which doesn't do a hell of a lot, but it does get a little bit of space saved. I'll think about that, although I do kind of want to have all the same chips, and the volume knob will be that much better for having 2 amplifiers on it, or so they say. Independent channels provide voltage control current. The device offers considerable flexibility. Operate on supplies as low as +8 volts. Portable high performance, blah, blah, blahs. 4 to 18 volt operation, low distortion, etc. But in the other data sheet, they talk about doubling it up. What is that? Temperature compensated exponential voltage to current converter. Jesus Christ, what is all this stuff? Voltage to current converter. What in the world? I don't think I need to have all this stuff. 1 volt per octave in, and then the output's up here. Yeah, there's a lot in this data sheet that I kind of need to process, don't I? But I mean, our schematic, what we have put together so far, does work. 2-pole resonant low-pass filter. Jeez. This is the mutable instrument design, or very similar to. It's got resonance. But there's a note somewhere around here about doubling them up. I was seeing extra channels. There's a lot of channels going on. Yeah, I spread them out so that you can see everything that's going on without it being too confusing. Where do they talk about that? It's like parallel. 2 or more channels can be parallel connected for further noise improvement. So that's essentially what I'm doing. I'm trying to get that little extra, the little extra something something about having Oh Bother design you an amplifier by doubling up on the components instead of getting a bespoke 2 amplifier version of this chip. Plus, I think that would make it even more rare and difficult to acquire. So having a V2164, a couple different manufacturers make these chips and resell them and stuff. So I think that's probably a good idea to just keep that in, even though the size of this chip is quite detrimental to the rest of this design. It's taking up quite a bit of space, this big-ass clunky chip that I've got going on here. Hey, Pyro's subbing. 70 months and lurking. How's it going? We're doing a sponsored AutoCAD ad. Oh, AutoCAD. We should really chamfer these corners. These should be chamfered in the design. We can do that later. But yeah, this so far it's looking like it will be possible using a 4-layer board, which is like, you know, 20 extra bucks. Using a 4-layer board that I might be able to fit the entire design on this thing. What's going to happen now, instead of me actually starting to run traces and everything, I think what I'm going to do is we're going to break for the holiday, and I'll probably do a stream sometime next week. But this is going to be possible. It's going to be extremely painful. It's going to be like ripping off Bane's mask. And so I'm going to have to go through this bit by bit and just pull teeth. It's just going to be tooth pulling. You know, using each amp locally as possible, trying to get all of my resistors and capacitors in there in the proper places, routing all the signal path. It might have to be that I put the second 2164 down here, and maybe U3 is going to be all the way down here under the plug, but then I need to somehow get the op amp in there too. Holy hell. This is going to be very difficult. This is going to be very difficult. But it's going to be sort of a step-by-step kind of ordeal. So maybe when we return from the break, I'll have a little bit more stuff on the board. Hey, Copper, you're just in time for me to kind of be wrapping up. We added a bunch of parts. We added the power connector and stuff, but we're like completely out of space. We're going to have to do some special stuff in order to get all these support components to surround these things. And there will probably be like a standard way to put down an op amp, and I'll have to modify that to avoid these pins that I'm going to have to hand solder. Yeah, we only have 10 millimeters to play with. So I'm definitely going to have to do a 4-layer PCB. I mean, look at all these support components that I'm going to need. That's all this stuff. Oof. So yeah, piece by piece, just take it little steps at a time. And the first thing to go down would be the signal traces. You basically, okay, when you're putting this together, what you're doing is you're viewing all of these air wires, and you try, where's the PCB? You're viewing all of these air wires that you've programmed the CAD program to have in it, right? And so what you try to do is place the components in order to minimize the spread of the air wires so that it looks a little bit more organized. So I will have to be going like piece by piece in order to get all of these resolved. It's going to be a sorted affair. But when we come back on perhaps Tuesday, I'm not sure, maybe Thursday, at the very latest Friday, when we come back, I will have a little bit more work done in this, and we can do a little bit of trace routing and stuff like that. So until then, happy holidays, Merry Christmas, happy whatever you want. Whatever you want me to say. I'm willing to say it. Look at that. And the cat's in the cradle and the silver spoon. Little boy blue and the man on the moon. When he coming home, Daddy don't know when. We'll get together then. It's just a total mess. Holy crap. This is gonna, yeah, it's gonna be a little bit rough at first. And then the other part is I'm gonna use a lot of gate swappings in order to get all of the op amps in the right places, because we don't need to make one chip specifically have all of the controls on it. We can spread it out amongst all of our same parts. Happy Tree Day, Merry New Year's. Hell yeah, brother. Where'd you go online to find high quality phone answering machine? This is for a landline. What? What do you, huh? Why are you asking me this? I'm designing a PCB. What in the world would... Fucking Twitch, man. Oh my God. Okay. Yeah, thrift store. Why would I know that? Why would I know anything about that? Copper knows. It's a local thrift store. There you go. I hope we answered your question, Your Highness. Jeez. Wonky Robot, thank you for the 100 bitums. I appreciate that very much. I'll be around. You know, I'm around. I'm here with the dog for the next couple days. And then I'm here for the holiday because we're having people over here. So yeah, I'll be around. I'll be on Discord. We're usually posting all kinds of irreverent crap over there. And I will be back with this design at the latest on Friday. And I'll have some update to it. Hopefully at some point I can sit down and really kind of like concentrate on it and figure out exactly where I'm putting stuff. And we'll use that in order to just kind of snowball into the rest of the design. We're just gonna roll with it, and I'll roll with it during stream, and I'll have enough for a stream. Right now, I really need to sit down and like start at one end of the design and go to the other end with little tiny baby steps, because this is kind of overwhelming right now. So we'll start with like one op amp. We'll do the main audio path and figure out what that's going to look like, and then build everything around that. But 4-layer PCB, it's my first time doing one, so this should be pretty interesting. I am going to hit save on everything, Control S. And then I will leave you guys until the next time. Friday at the latest. Don't pay attention to what the command says. But here is, let's end poll. Wait a minute. Here's the end card. Damn it! Curse you. I typed /end and it confused me. Yeah, B-Sky. I'm on B-Ski. And of course, Discord. Join us on Discord. Hang out. I will be back in a little bit. But I'll see you guys then. Until then, I'm going to go walk the dog in the snow. Catch y'all later. Oh shit, I'm still live.